Okay, so I'm gonna have a recording. We don't have the other guys yet, so maybe we'll wait a few minutes. Um, but everything that we're doing today is recorded and will go
Oh, good.
into the Dropbox so that you can go back to it later if you so desire and look at what we're going to talk about. All of this stuff has been updated in my Dropbox, so slide decks have changed, things like that. Everything's updated, and there's new data all the time because newer papers get published, or I find older ones. We'll be talking about that issue today as well, because there's a lot of really good research that was done in the 60s, the 70s, and the 80s, and like the case with diabetes, for whatever reason, it's been ignored or forgotten. But there was a lot of really hardcore biochemistry that was done in those decades on gout, and we just don't hear anyone talking about it aside from me and Johnson. When Johnson talks about fructose uric acid metabolism, he will reach back into some of the papers that I'm going to talk about today, but I'm more specialized. All right. It could possibly be just you and me. Well, let me wait a little longer.
Yeah, I'm happy to wait.
StreamYard is, I found with some people, they have a hard time getting to it. Let me just check my email really quick and see if anyone's freaking out.
Yeah, and I'll just grab a pen that works. And if it turns out just to be us and you want to schedule another time, throw me into another group. If you have that, I'm happy to do that as well.
Oh, no, unless I know it's really late for you, but unless you're like completely exhausted or whatever, I'm ready to go with this and to give you
I've been to bed. I've been sleeping.
highest quality option to get to gout remission that I can. It looks like somebody else is trying to join.
Good.
But their device is not connecting. I don't know what's going on with that.
Depends if they're using Safari, I suppose. COVID's helped with a lot of the technology, but we're not there yet, are we?
No. Okay, it looks like we have them now.
Excellent.
Oh, can you guys hear me?
Yes.
Okay. Yeah, my I don't have a mic. I'm sorry, I don't have a camera on this computer, but I've got I got the mic working. Never done StreamYard before, so.
Okay, yeah, no worries. All right, it's 7:05, and I think that we're going to go ahead and get started. So I sent you guys out a Dropbox link. I'm going to send it out again after today because I will have added the MP4s from the session that we're doing today. So as I was explaining to Jack, he was a little bit early a few minutes ago. You will have all the recordings from what we do today so that you can access it later because we are going to go through a lot of stuff. You're probably going to get really tired. Feel free to interrupt me and you can ask questions. The first thing I want to let you know is that in the Dropbox, there's a 30-day menu in there to give you an example of how I cycle through what I eat and how I do my own meal plan. It also has recipes. There's a list of blood work. And when I get into the formal presentations here in a second, I'll explain why this is important. But if later you want to know, all right, because with gout, one of the central things you've got to realize is that it is an endpoint of the maladaptation of metabolism. So if you're suffering from gout, the likelihood that you don't also have other comorbidities is actually pretty slim. And the way that you, at least initially, the way that you can try and understand that is by getting additional blood work done. I have people right now in this room from different countries, so everyone has a different health system. But here in the US, you probably have to pay for the blood work yourself. The insurance company is going to come back and go, well, there's no reason to do this blood work. And so just be aware of that. There is an expense behind it if you're in the US. I left the past recordings from the last Gout Intensive in there, so you can access those if you want. It's up to you, different people, different kinds of questions and things like that. There's an ebook in there that explains the meal plan, and this may sound like I've already talked about this. I did say something about this, but this ebook, the advantage of it is that there are links to recipes that are on YouTube, so that you can literally, when you look at the recipe, you can click on the link and then it shows exactly how to make the food if you need that. And then there are color-coded food lists, and everyone on the internet has color-coded food lists for low carb. But this is there if you want to use it. And then there's also a 100 recipe booklet that my daughter and I put together that you can utilize. All of that is in there. And then at the end of today, sometime over the afternoon or tomorrow, I'll have all of the MP4s from today uploaded there. We're going to get one long recording here, and so the time delay is in me taking that and splitting it into the presentations basically, and then uploading those. I put them as unlisted videos on my YouTube channel. So when you're clicking on the link, it's not going to a regular YouTube video. Only you have access to it on that. Okay, so do you guys have any questions before we start?
No, I'm right at this stage, thanks.
Okay. Yeah, I was able to get it in the Dropbox, by the way, so no issues there.
Okay. That's good.
I haven't got any of those emails, Pete, so we'll catch up on that.
Oh, all right. Well, I'll be double checking today when we're done to make sure. I'll send out another follow-up email with all of this stuff in there. So, all right. All right. The first thing I want to address is that I have a lot of experience now over the last 5 years working with people, both in gout remission and also reversal of diabetes. I've seen the whole spectrum. I've worked with people with chronic kidney disease, serious cardiovascular stroke issues. Down the road we go. So I want to talk about or introduce at the very beginning some of the issues that I see with those of us that suffer from these chronic diseases, and then find ourselves looking at a realization where we have to change our lifestyle, and just talk about some of those emotions quickly, and these are all things that I went through, but sometimes with some of the clients that I've had, these issues actually become impediments with being successful. So the first thing is that this lifestyle change takes time. The issues that we have in our joints, the fundamental metabolism we have there, and I'm going to be getting into that, represents the same fundamental metabolism that's driving type 2 diabetes. And I don't want to get ahead of myself, but all these different maladaptations to metabolism because of the way predominantly that we're eating. There are other factors involved in lifestyle, obviously, are the sleep, exercise, and those kinds of things. And I'll talk about that a little bit today. But generally speaking, in the beginning, there's a fair amount of disbelief. This is something that I went through. It's something that everyone else that I've worked with has had issues with. It's like, wait a minute, my establishment's been telling me that I'm eating a balanced diet and yada yada, and how can this? Why me and essentially nobody else? And there can be a lot of fundamental denial involved in it. That I'm eating correctly already, and this is not possible. And these are some of the barriers that it takes one to get through. Now, I am somewhat different than a lot of the other people out there in this space, and I don't spend my time on YouTube or in the electronic forums where I'm at talking about the bullet points in terms of chronic disease and how we reverse them. I get specifically down into this, but one thing that I want you to understand going into this is that when you look at the analysis that are available now on the internet, it's clear that a significantly high percentage of our Western population suffer from chronic metabolic diseases. The figure is actually over 88%. So one of the issues with getting gout into remission and going, making a change in lifestyle and all of this that we're going to be talking about today is dealing with the social aspects of this. Spouse, the people that we go out to dinner with, good friends that we do things with, because there's going to be can be a great amount of skepticism that's used as pressure on us. Surely you can have a little bit of this. Surely you can have this. It's, you've been eating this way now for years, and you can take a break. So number one, remember that we do need to change the way that we eat. And unfortunately, and I've had clients that used to ask me, does this mean I have to do this the rest of my life? And the bottom line is, most likely, this is a true thing. It's probably the rest of your life. That's number one. And number two, though, remember that this person that's putting pressure on you is probably metabolically ill. And either they have no idea that this is the case, or they do know, they've been to the doctor and the doctor said, you've got high triglycerides, your HDL is low, and there are other issues, maybe an elevated A1C, whatever, all of these different things. And they're choosing to not recognize it. So basically remember that when these things are coming at you. And then there can be anger and frustration. I know I was really angry when I first sorted out that this was going on with me, because I suffered from gout. My first diagnosis was in 2016, and then later with prediabetes in 2019. And, when the doctor alerted me, which wasn't even in a face-to-face conversation in terms of the prediabetes, it was an email. I was a third-year CrossFit athlete, and, the email was like, eat a Mediterranean diet and get more exercise. And I was already in the gym, a ridiculous amount of days per week. And I was pretty angry about that. But there can also be anger coming in on another level too. And that's when you sort out, when you find out, when you get underneath the establishment literature and you find out that, we're going to talk about this today in gout, when you find out that the science has been here for a really long time, and for whatever reason, it's not being talked about. People aren't being given these options. And that made me angry, and then the frustration to deal with it. The next thing is, most people, and this is anecdotal, I have a survey on my YouTube channel, and I'm starting to get a flow of data coming in. And after we're done, maybe in a couple of weeks, you guys would be willing to go there and answer the questions on that survey for me. But basically, most of the people that are responding to that, greater than 75%, who have made the changes that we're going to talk about today, have seen their gout situation improve, which is good, right? Because as I explained to Jack a little bit earlier, I'm going to be talking about the science behind all of this, and piecing together science is coming from a lot of different disciplines. Because as a trained biochemist, the one thing that I learned when I was working through my doctorate and my dissertation many, many years ago now, we were trained that when there was a problem to solve, that we needed to go out and turn over all the stones. The biochemists who were really good were the ones who reached outside their disciplines, asked questions, and used that knowledge to solve problems. And one of the issues that's facing us is the fact that our establishment tends to stay in their own lanes. Whatever their discipline is, they stay in the lane. And as long as that continues, that doesn't bode well for people like us that are suffering from these chronic diseases, and then we're looking for solutions. So, and this is important for ourselves to realize, that lifestyle changes take time. That's the other thing. So you can't, if you're sitting back right now thinking, all right, this is a silver bullet, I just want to know what I can put in my mouth, like a pill or something like that. We do not have anything like that for gout. And if you follow stuff on the internet, you know that Richard Lustig has talked a lot about this. These metabolic diseases are not druggable. We have to change the way that we're eating, and there are other factors, I'll get to those today, that contribute. And then it takes time, especially if you're like me. I was 60 years old when I was diagnosed with prediabetes, and 57 with gout. And that was decades of the standard American diet, with my vices, the sugar and also alcohol consumption. And we can't expect to get out of that. We can't expect to get out of that, in the matter of a few weeks. This takes time to recover because there's damage in the pancreas and in the liver, in the kidneys, in the chondrocytes, which are the biological cells that are in the joints. All right, so we're going to start very quickly. This is the definition of gout. And if you go out on the internet and you look at all the various associations, the standard of care and all that, this is what the medical doctors think causes gout. So generally, people will have hyperuricemia. That means they have high uric acid chronically. This diffuses into the joint, where it crystallizes. This is a very simplistic model. You get these sharp needle-like crystals that are then agitating the tissue in the joint. You get the pain, and so on down the road we go. Well, one of the things, and I'm going to lay out the case for this carefully now, is that this hypothesis is not correct. All right. And there are other trends like this. I don't want to get off on a tangent here. There are other hypotheses in chronic disease that the medical establishment uses that are also overly simplistic. And because they're so simplistic, they're wrong. And so coming up with a hypothesis of gout is fairly important. Now, this morning, we're going to talk about a lot of biochemical data that was published in the 60s, the 70s, and the 80s. And this is very important data. It was done by biochemists in biochemical labs. Those guys were incredibly rigorous. For some reason, a lot of the data, well, most of it that came out back then has essentially been forgotten. And this is problematic for us. We see similar trends. If you look at the history of diabetes, for example, we knew that low-carb diets were working for those going way back, even before epilepsy, right? And a lot of the influencers, when they talk about the advent of low-carb, they'll bring up the issue of the epilepsy. But honestly, there were diabetic doctors that knew about low-carb before the epilepsy story. And so the point being that it's important to know where we came from in order to make decisions now about conditions that we have. Remember, there's a lot of stigma attached to this. Over half of us don't really want to talk about it. It's taken me a lot, even among my friends, before I was willing to say, well, I'm not drinking tonight because I've suffered from gout, and this is one of the central drivers of it. It's because when we talk about it, there's this picture of a gout sufferer out there that looks like somebody who's just sitting around deliberately overeating fast food, drinking alcohol and sugar and all of these things. And we know I have yet to meet anyone who fits that stereotype, right? In this, mostly we're people out there that actually thought we were doing the right thing, but figured we had a couple of vices, and then down the road, all of a sudden this stuff hits, and it's like, well, what did I do wrong? You feel like you're a bad person. So an individual, first off, needs to get over this. And I think I mentioned a little bit earlier, remember that there's more than 88% of our population in westernized cultures that are suffering from metabolic diseases. We're not alone. And usually somebody, when I'm discussing gout with them, kind of look down their nose at me. I've gotten used to that sideways glance or whatever. It's just understanding that those guys are in as bad a shape as we are probably, but they just either don't know it yet or they're in denial about it. So one of the key things that's really important to understand about gout is that it's one endpoint possibility of a whole bunch of chronic diseases that are being driven by fructose uric acid metabolism. But even as I say that, we need to be careful in our own space not to isolate the idea of fructose uric acid metabolism into its own unique pathway. One of the concepts I'm going to talk about this morning is the fact that this pathway is integrated with the main metabolic pathway that funnels glucose into the mitochondria called glycolysis. These things don't operate in isolation. And this is one reason why you see so many engineers who have gotten involved in the metabolic space, because the one thing that biochemists and engineers have in common is we look at these problems in terms of systems, not as isolated entities. It's a mistake to look at this as an entity that is unrelated to anything else. But there is a tremendous amount of published data that goes back decades. A lot of it was done by Dr. Richard Johnson. I've got those references in the slide here. Decades of work, over 700 publications. And we know that fructose uric acid metabolism, when it's activated, and this is going to be the key thing here, drives kidney disease, diabetes, obesity, fatty liver disease, Alzheimer's, cardiovascular disease in all its different forms, coronary artery disease, and so on, and sugar and alcohol addiction. And I have that in red because just mentioning the word addiction usually makes people run out of the room. This is a stigma. People don't want to talk about it. But, and I probably will mention today some of the direct connections to the brain via this metabolism. And it's something that gout sufferers have to talk about. And the reason that we do is because if you are consuming alcohol, alcohol is one of the main drivers of this pathway, along with sugar. And they activate the same pathways in the brain, the dopaminergic expression system, food reward system, and a very specific protein there called delta phos-B that literally directs our need to go back to that eating environment and reconsume those things. So this isn't a discussion today about sugar and alcohol addiction. However, we need to consider that here because some of us in the process of putting gout in remission may indeed have to struggle with the issue of giving up sugar and giving up alcohol. So we need to have it on the table and just make sure that we consider it. Now, something very important to gout sufferers is the fact that if we are suffering from gout, this is not a unique singular disease. It's driven by the same central fructose uric acid metabolism integrated with glycolysis and the mitochondria. And when we ask the question, okay, I'm a gout sufferer, what other comorbidities am I probably also suffering from? Well, 74% of us are hypertensive. I know that was true for me. It's not true anymore because I've been living the lifestyle I'm going to be talking to you guys about today for 5 years, and my blood pressure now is in the normal range. 71% of us suffer from chronic kidney disease. That's true for me. I'm still not sure where that settled out. Over half are obese or significantly overweight. A full quarter are also type 2 diabetes. I was diagnosed with prediabetes in 2019. I didn't know when I was diagnosed with gout, I had no clue at all that if I was a gout sufferer, that I probably should also be analyzing these other blood markers to see what else could possibly be going on. Because again, gout is treated like a sliver in the finger illness by doctors most of the time. And the one thing I hope you can get from all the discussions that we have today is that it's not a sliver in your finger. There's a certain amount of people that also suffer from about a quarter of also the kidney stones. And then about 10 to 14% suffer from cardiovascular disease or some form of coronary artery disease. So the whole thing is, if you are suffering from gout, you have a recent diagnosis, you really need to sit back and ask the question about these other things, because the probability that you're not suffering from something else also is pretty slim. Now, I want to deal with the hypothesis that the current medical establishment has. We have to, because the first clue that I had when I started looking at this question 5 years ago, this was the data I looked at, and you can tell just from looking at the statistical data that there's something wrong with the hypothesis. So the first thing is, in the US population, about 4% of that population suffering from gout. there's 43 million people walking around that are hyperuricemic. That's more people. And when I say hyperuricemic, I mean high uric acid. That's more people than suffer from diabetes. That's something to think about here, right? About the average or the mean concentration of uric acid in a gout flare is 8.3 mg per deciliter. So understand that the normal range, if you have your blood work done and you have uric acid measured, the normal range is going to be on that sheet of paper is going to be between 4 mg per deciliter and usually 8 mg per deciliter. Some labs will have the upper range at 7. So it's between 4 and 8 pretty much. Now, when you look at the percentage of gout sufferers, 18% of somebody who's suffering a flare will have uric acid between 6 and 8 mg per deciliter. And when I first was diagnosed with gout, my uric acid was 8.1 mg per deciliter. So right at the top of the range. Yet when I was speaking with my doctor, they talked to me as if the concentration of uric acid in my blood at that point was like this skyrocketed value. And that's just not true. Most gout sufferers are suffering from gout with relatively low ranges of uric acid. And we see that some people, up to 14%, are actually under 6 mg per deciliter. And as I talk to you today, I can tell you I had a flare when I went on to allopurinol, and I'll talk about that whole issue down the road. But I had a flare on allopurinol where my uric acid was 4.5 milligrams per deciliter. And what that tells us right out of the gate is that a gout flare, and I'm very confident in this, while a gout flare requires uric acid, no argument there, it's not sufficient to cause the flare. There are other factors that have to be involved in this. Because how else do you explain that we've got millions and millions of people walking around that are hyperuricemic, high uric acid, and yet a majority of those people will not ever suffer a gout flare for their entire life? And so the uric acid is required, but there are special conditions we're going to get into that. The other thing is that in people that are hyperuricemic, high uric acid, and some people, well, let me slow down. So in some people that have high uric acid but aren't suffering from gout, when you aspirate, you stick a needle into their joint, you pull synovial fluid out. In some of those people, you can find crystalline uric acid, well, monosodium urate in there. So having the crystal does not mean that you are going to have a gout flare. So anyway, what's the point? The point is uric acid is required for the flare, but it can't do it on its own. So there are other conditions, and I'm going to argue that these are specialized conditions. And what we need to do in the future is understand completely what those conditions are if we're going to put gout in remission. Okay, now this work came from the 60s, the 70s, and the 80s. And I'm putting this out there now because I was just talking to you about epidemiological work, statistics. What does that mean? And I'm not going to overstep the epidemiologically and start talking about cause. Here, in very clear-cut studies that these guys did, they had individuals that were not suffering from gout. And when they extracted synovial fluid in some of those people, the fluid was milky white with monosodium urate crystals, and those guys were not suffering from gout. So this evidence is unequivocal that, and they know, before I pass this slide, they knew, for example, they did the opposite experiment. And some of these doctors were very brave individuals. What they did was they made crystalline monosodium urate in the test tube and then literally injected it into their own joints and generated the gout flare. So what's the point? The point again is that, yeah, you need the crystal to have a gout flare, but the crystal in itself is not sufficient. They understood that the synovial fluid of somebody who was not a gout sufferer was fundamentally different than the synovial fluid of somebody who was a gout sufferer, that there was something special about the conditions in the fluid that's surrounding these biologically important cells, the chondrocyte, that are in the joint, that are responsible for the homeostasis of the joint, that when you get the formation of this crystal with these other factors that are present, then you could get the gout flare. So the main thing is to understand that uric acid is required for the flare, but there are cellular factors that have to be in there in order to have the flare. Okay, so I'm just setting the stage for this. I don't want to get off into this tangent yet. But again, what I want to emphasize is that there are specialized conditions that have to be met along with the crystal in order to get the gout flare. On the left is the typical joint where people tend to have gout flares. For me, it's the next joint back behind this one where I get my flare. Some people will have the flares in their fingers. Some people will be in the knee. When you really look at the literature hard, it turns out that sometimes gout can be symmetrical. And what I mean by that is that there are some people, when they have a flare, where it will be in both the left and the right foot, or the left and the right knee, or the left and the right, hands, depending on, which fingers. It can be symmetrical. Again, this is alarming because it's not acknowledged. And one thing I'll lay the groundwork for right now is that there may well be, there's some data for this, that there can be other crystals that are involved in gout flares. And I'm going to use the term gout flare now with quotes around it to suggest that you have this inflammatory condition, but monosodium urate may not be the only crystal that's involved in this active, painful flare. The most obvious candidate for this would be in combination with calcium pyrophosphate. Now, on the right, you can see a human spine here. This is somebody who is complaining about back pain, lower back pain. And this is an advanced type of CT scan where they're using different kind of algorithm and visualization process. And what you see in green there is crystalline monosodium urate. So you can have when you have the specialized condition that you need to have a gout flare in your toe, it's possible that you have specialized conditions in other areas of your body in the connective and soft tissues there that are very similar to the specialized conditions that you have in the joint in the toe. And so it is possible to have crystalline deposits of uric acid that are causing a gout experience in other locations of the body. Now, I am known for talking about the science. Sometimes people really criticize me over this because they're like, one, we can't understand what the hell you're talking about. And secondly, the other issue is that they say, why do we need to know this? Can't you just tell us? And the first thing is that I struggle very hard to try and deliver this as clearly as I can, but we can't ignore the science. If we ignore the science, then I'm treating you exactly the way I feel like the establishment was treating me and the rest of us when they started waving their hands and they're like, well, you're suffering from gout. Here's some allopurinol, and that's going to make it go away. And I'm going to talk about, we're going to get to the issue of urate lowering drugs, but gout is not druggable in the way that we're talked about. And the basic reason we get into these things is because the science is not being addressed. So years ago now, it's actually been quite a long time that I've been looking at this problem. When I saw Dr. Richard Johnson's work on fructose uric acid metabolism, and I knew at that point that uric acid was required for the flare along with these other factors, fructose uric acid just literally jumped off the paper at me. And this is an obvious place that we need to go, because the likelihood that we have this going on in our joints or related to what's going on to the joints is quite high. So in this diagram, what I want to do is introduce the concept of this metabolism and how it's related in general to the metabolism of a human. So on the left in gray, you can see the glycolytic pathway. And the glycolytic pathway is connected to the mitochondria. The main purpose of this pathway, when we have a meal in which glucose is coming in, I'm going to use a term, at a normal level. So we're not eating a meal that is deliberately high in glucose, creating what I'm going to call hyperglycemia. Now, trying to understand what a normal level of glucose is in the literature is really difficult, because all of the labs that are looking at the issue of diabetes, for example, which is mainly where this data is coming from, they use different conditions, and there is an argument about where hyperglycemia starts, and if it even ends somewhere. And the starting point is important to us because the whole point of glycolysis is to produce energy, to allow us to store, once we're meeting the needs of these various organs where this is going on, like liver, kidney, brain, etc. Down the road we go. All right. The incoming glucose is being processed to produce ATP, which we need in order to function. When we have enough of that, we've reached some homeostatic level, then the rest of the glucose coming in is going to be used to top off our glycogen stores. And some of it, if there's enough of it coming in, will be used to produce a little bit of fat. Now, where we run into trouble in the standard American diet is that once the glucose loads exceed a certain level and we move into a hyperglycemic load, and in meals like this, there's usually added sugar as well. So we're going to have also fructose coming in. I'm going to call that type of fructose exogenous. If this is an evening meal, then if we're talking about adults, there's a really good chance that they're also having alcohol with that meal. And then in addition to that, if the food is processed, then we also have incoming what's called umami. And these are going to be foods that are very high in the amino acid glutamate. This also can include overeating certain types of meats, like going full bore in a sushi meal, a ton of tuna, could be, and I've had this example, somebody that wrote into me, they could be an afternoon of eating anchovies and drinking beer in the pub, right? Where we have a tremendous high load of the oysters coming in, which provide a very high level of glutamate. All of these things together activate fructose uric acid metabolism. And in the case of a standard American meal, as soon as we get to the point where the glucose has moved into the zone of hyperglycemia and or with these other factors that are available, then we open fructose uric acid metabolism. The glucose gets funneled into the production of what we call endogenous fructose by the polyol pathway. And once the fructose metabolism is operational, and if you're wondering why would humans have a pathway like this, once it's operational, then we actually change the state of the liver. And we also change the state of any other organ system that's operational with this, including the chondrocyte, so that it moves from a state of burning, the production of ATP, and the things that I talked about with that, to being completely in a storage mode, so that all those calories that are now coming in are being converted into fat via de novo lipogenesis. We have a sudden acute decline in ATP at that point in the liver. And we have a sudden decline in phosphate with a sudden acute rise in uric acid. And uric acid is a signaling molecule. It's not inert, and it's not a waste product. It is a signaling molecule. And I will talk a little bit later about what my ideas about are with what that thing is doing. But the major issue here is that it's opening up de novo lipogenesis. We'll get into some detail on that. It is activating systemic inflammation with key activation of certain proteins, one of which is actually involved in the inflammatory event that we have in a gout flare. And it causes the dysregulation of nitric oxide balance, which bodes really badly for those of us downstream that could be suffering from cardiovascular disease. This is one of the central drivers of cardiovascular coronary artery diseases, the disruption of the nitric oxide pathways. So now we're going to look at this in a little bit more detail. And again, one of the things that happens once in a meal that goes hyperglycemic is we do activate polyol pathway in the liver, and the fructose pathway, I'm going to mention this over again, is now in terms of comparative rates. If we compare the rate of fructose uric acid metabolism once this is opened, hyperglycemia, added sugar, alcohol, and the umami, is that pathway is operating at 10 times the rate of glycolysis. Just think about that for a minute. Now, there are three main things I want to emphasize in this slide. When we're out there trying to understand all of this metabolic disarray, most of the influencers are going to talk about the fact that insulin resistance is the major issue here. And if we're hyperglycemic, for sure we have an issue with elevated insulin, right? We know that that's going on. The hyperinsulinemia, and downstream of that, the insulin resistance. But one of the questions that needs to be asked is, what is the mechanism that actually is driving a significant amount of that insulin resistance? And here you're looking at it. Once we have activated fructose uric acid metabolism, we generate, or we activate, or we induce the production of these proteins. Some of these are kinases. That's Russian for, these are proteins that are putting phosphate groups on other proteins, or we have phosphatases. These are enzymes that are removing phosphate groups. The point is, we generate this inflammatory state. And one of the proteins that's going to get produced there is JNK1. Another is IL-1 beta. And these influence the insulin receptor that is on the membrane of the liver and disrupts the signaling there, downregulates it. So now the insulin that's interacting at the level of the liver is no longer having its normal effects on modulation of the glucose that's being worked on by the liver. And in addition to that, and this is something that we don't see talked about at all right now at the level in our own space, is the fact that we also have an effect when these proteins are elevated on insulin extraction. one thing that you guys got to recognize is that about 50% of the insulin that is produced by the pancreas that then arrives at the liver in the portal vein, 50% of it is extracted by the liver and removed. So when we have the disruption of the signaling at the level of the insulin receptor, some of that receptor is actually removed. It's removed from the membrane. So now we have less insulin extraction. And think about what that means. That is going to cause hyperinsulinemia, and then it's going to contribute significantly to the insulin resistance that's happening downstream. And when I say downstream, I mean at the level of skeletal tissue, adipose, anywhere else insulin is going to be operating in the circulatory system. We also have the uric acid is going to interact with an enzyme called NADP oxidase, and it's actually translocated into the mitochondria. And the big effect there is it interrupts the Krebs cycle. And at the level of the citrate, where the citrate would be converted into another molecule that's called isocitrate. That detail in itself, I don't expect you to remember. But what happens is we interrupt that cycle. And the citrate now is pushed into the cytoplasm from the mitochondria. And in the cytoplasm, you can see in yellow there, that citrate undergoes this overall process called de novo lipogenesis. In yellow, there are two transcription factors here. You can see the carbohydrate regulatory element binding protein, that's the ChREBP, and also the sterol regulatory element binding protein 1C. I know these are complex, but these transcription factors are activating the production of de novo lipogenesis enzymes at the level of DNA. So what's going on there in English is that the liver now is being completely reprogrammed and going from a state of burning. The ATP is no longer producing ATP. It gets shut down and basically starts pushing the citrate out. There are other intermediates that are going to get pushed out too. But the point is we end up producing oil droplets literally right in the liver. This is the origin of non-alcoholic fatty liver disease. And then much of that fat is also repackaged and pushed into the circulatory system as VLDL. And this is explaining why people that are diabetic are tending to run very high triglycerides in their blood. This is it. You're looking at the mechanism. So we have this activation of de novo lipogenesis at the level of the liver, and anywhere else where this metabolism is happening, and we have it in brain, skeletal tissue, adipose, at the intestinal level. I'm probably forgetting some of them, and I'm going to show you data today for the chondrocyte as well. Not all of this happens exactly the way it does in the liver. And I'm not arguing to you that it does. There are nuances. There have to be, because all these different tissues where this metabolism is active have different functions. And as a result, the response of these pathways to hyperglycemia in particular, that's going to matter to us in the chondrocyte, is going to be different how everybody deals with this. But with the systemic inflammation and whatnot, there are commonalities. Now, this last part is really important to us as gout sufferers, because the third major effect here is that when the fructose uric acid metabolism is activated, the hyperglycemia, presence, incoming alcohol, added sugars bringing in exogenous fructose, and then the umami. The top end of glycolysis is inhibited during this transition. Up to 30% of the glucose coming in due to hyperglycemia is going to be funneled by the polyol pathway into endogenous fructose. Remember, this pathway is running at 10 times the rate now of glycolysis. And there's a consequence. And that consequence is we're going to back up these intermediates that you see in turquoise, dihydroxyacetone phosphate and the glyceraldehyde, which now are going to be pushed back into the lower end of glycolysis. And this is going to functionally have a number of effects. Number one, it produces a trickle, the reformation of ATP. This is important because it's going to allow the liver or the chondrocyte, wherever this is going on, to be able to maintain its basic functions. It has to be able to maintain the basic functions, while on the other hand, you have this storage issue going on, the production of fat, the systemic inflammation, these other things that are happening. All right. More importantly to the gout sufferers is that you have the formation of acidosis, number one. So when you look carefully at this pathway, you have this elevation or production of hydrogen ions, which causes a decrease in pH, or am I saying that right? Yeah, decrease in pH, increase in acidity. And as that acidity rises, much of it is going to be pushed into the extracellular area. All right. Additionally, we have a strong activation and production of lactate. And the lactate, as it rises, is going to be also pushed out into the circulatory system, along with on an equimolar amount. What do I mean by that term, equimolar? So for every lactate dude that gets shuttled out, one hydrogen ion dude also is shuttled out. They go together. And in the gout situation, this is going to cause the extracellular matrix. And I'll give you data for this. This is going to cause the extracellular matrix, the fluid surrounding the chondrocyte, acidic. And the acidic nature of that synovial fluid is going to have consequences for us. It's going to cause the release of calcium. And before jumping ahead into that, before I get to that point, there's another consequence of the lactate. And lactate is going to be shipped all around because of the circulatory system. And I could go on presentations about lactate in itself. It's a very serious molecule. But one of the things that it does that matters to the gout sufferer is that as it rises in the circulatory system, it's going to be pushed into the urine at the level of the kidney. And when lactate is being pushed into the urine, it competes with uric acid. So remember, in the processes that I'm talking about here, you have this acute rise in uric acid, which is also being pushed into the circulatory system, right? Because the liver is going, wow, there's too much of this here. Get it out, right? Because it's doing all these intracellular things, some of which evolutionary were good for us, right? Because it allowed humans to be very responsive to certain macronutrients that we were eating, to rapidly convert that stuff into fat, so that we had the energy to be able to do what we needed to do to go out and get our next meal. But as the uric acid rises in the circulatory system, there's a limit there too. And that uric acid is going to get pushed out into the circulatory system. Lactate is being pushed out in there. And as the lactate is pushed into the urine at the level of the kidney, it actively competes with the uric acid, so that we get a spike in uric acid in the circulatory system. And as this story unfolds here, you're going to see why that's not going to be good for us, right? We don't want uric acid spiking in the circulatory system. And this is besides the fact that alcohol activates this pathway, right? It activates the polyol pathway. And in the presence of the glycemia, That's double trouble for us. But alcohol has another effect. And that effect is to also cause the overproduction of lactate. And so if you have somebody that's eating the standard American diet, it's hyperglycemic, they have added sugar coming in, and they're drinking alcohol at the same time, not only are you spiking uric acid in the circulatory system, you're also spiking lactate out there because of the alcohol effect. And in addition to that, because of the Warburg effect that we're talking about here. So this turquoise that you see, you're looking at the famous Warburg effect. And it's going to matter to us because there's data that shows that the chondrocyte undergoes a metabolic shift during hyperglycemia to Warburg, mirroring exactly what we're talking about here, the elevation of acid, the elevation of lactate. Now, if you're with me, you can understand that as this spike in uric acid happens in tissues that are uric acid producers at the level of the liver and also in the kidney, it's going to get pushed into the circulatory system. And it's necessary that I mention that we talk just briefly about the laws of diffusion. Uric acid is a small molecule, along with glucose, along with fructose, and other small molecules. And we know that uric acid follows the laws of diffusion, and it can freely diffuse from the circulatory system into and out of other tissues. So the thing you've got to understand, and I think out there, that the doctors that talk about gout, I think a lot of them don't get this, that when you have high uric acid in a compartment, it will diffuse down its concentration gradient from the compartment where it is at a high concentration to the compartment where it is at low concentration. And that transition will occur until the uric acid in both compartments is equal. And there's nothing you can do to stop that transition. The only thing you can do is slow it down. So you can talk about putting up barriers and all that kind of stuff. It's like, so what? Eventually, the compartments will equalize. And that's something that a gout sufferer needs to keep in mind. Because when we get a uric acid spike happening in the circulatory system, that uric acid is going to diffuse all around into these other tissues, including our joints. So, and I'm going to make an argument for this going forward. We can have uric acid coming into the joint of interest where we have our flare from the circulatory system. And we also can have a production effect, which I'll be getting to. And more than likely with gout sufferers, we have to be conscious of both issues. This just illustrates what I'm talking about. Circulatory system on the right. When uric acid is high, it's going to diffuse into all tissues that are connected. Brain, kidney, you name it, right? We can have the free movement of uric acid into those tissues. Now, I mentioned already, I laid some groundwork for this. So the big question that we're going to have in gout is, how does the uric acid get into the joint? One way we know is via diffusion. It can get there by simply coming in, diffusing down its concentration gradient from the circulatory system into the synovial fluid. And in fact, we know that that is the case. You can see that data in the 3 papers I'm showing here. But strikingly, these guys looked at the concentration of uric acid in the synovial fluid of gout sufferers by comparison to osteoarthritis people, rheumatic arthritis people, and so on. And what you can see when you look at that data is that in the gout sufferers, the uric acid concentration is actually higher than it is in the serum. And the only way that you can explain this data is, well, there are two explanations for this, to be completely upfront about it. But the one that I favor is that the chondrocytes, the biologically important cells in the joint that are, whose function it is to run the joint, are actually producing uric acid and pushing that into the extracellular matrix, into the synovial fluid. And you can see when you look at this data that the concentration of uric acid in those individuals is higher than the serum. Whereas when you look at these other arthritic individuals, osteoarthritis and so on, you can see that the uric acid in the synovial fluid is slightly less than the uric acid in the circulatory system, which is what you would expect if uric acid is diffusing from the circulatory system in, right? The only other explanation for the higher level of uric acid in the joint would be if there is an active transport mechanism in the synovial membrane. And what do I mean by that? I mean literally a molecular pump that requires energy to push uric acid against a gradient. And when you look at the data for this, you can't find any. As far as I know, a process like that does not exist. So the best explanation here is that the chondrocyte is actually producing uric acid under the conditions of a gout flare. So now when we turn the page and we say, all right, what is the chondrocyte capable of? What can we find in the literature that it, in terms of its biochemical identity, what does it do? And what are the typical conditions that the chondrocyte is faced with? And we see that in synovial fluid, that during a hyperglycemic meal, starting on the right side of my slide, that the concentration of glucose reflects the concentration of glucose in the circulatory system. Same with fructose, right? Uric acid, the concentration of uric acid found in synovial fluid reflects what we find in the circulatory system. So that means it's diffusing down its gradient. Free fatty acids can diffuse into the synovial fluid with no problem, and even ATP. When we ask the question, what are the functionalities in the chondrocyte? We see that number one, the chondrocyte has GLUT5. This is a transporter that allows functionally the chondrocyte to transport fructose into the cell. So if fructose is there, it can enter the chondrocyte. But more importantly, the chondrocyte has GLUT9. And GLUT9 is a uric acid transporter, both out of the cell and into the cell. And what this means is that if uric acid is present in the synovial fluid and it rises to a higher level because of a spike in the circulatory system, that uric acid can be transported into the chondrocyte. And we have data that suggests, especially in the area of kidneys, that if you have the transport of uric acid into the cell, it can elicit the same intracellular effects that it does if it's produced in the cell directly. We know that the chondrocyte produces JNK1, and this is a protein that is involved in systemic inflammation, and it also has been shown to be instrumental in formation of the key inflammasome that causes the inflammatory event of a gout flare. You have to have JNK1 in order to have formation and activation of the NLRP3 inflammasome. And then lastly, uric acid is known to also activate IL-1 beta along with hyperglycemia in the chondrocyte. And IL-1 beta is a cytokine that is at the pinnacle, at the top of the inflammatory cascade. Now, what are the conditions that we typically find in the synovial fluid surrounding the chondrocyte. Hyperglycemia is typical. There are hundreds and hundreds of papers published from the area of osteoarthritis that have shown that when somebody has a standard American meal that is hyperglycemic, the synovial fluid is also hyperglycemic. We know that there can be high levels of lactate and hydrogen ion. I've already introduced the metabolic conditions that can generate that. We know that the synovial fluid can undergo significant fluctuations in ions, generating osmolarity differences, or changes in how ions are dissolved in the fluid versus what's inside the cell. And the issue with this is that osmolarity is one of those things that can activate fructose-uric acid metabolism. We know that the joints are hypoxic. So when we look at, you can look this up anywhere on the internet and get yourself a schematic of a typical joint. Where the capillaries meet the synovial membrane, there is a hypoxic gradient that starts there and then moves inward, meaning that everything that's diffusing into the synovial fluid does so down a gradient, meaning that where oxygen is coming into the synovial fluid will be at a high concentration relative to the circulatory, equivalent to the circulatory system or close. And then as it diffuses into the inner part of the joint, the concentration will go lower. So the chondrocyte is a cell that has evolved to operate in a hypoxic environment. And the data shows that it actually undergoes a metabolic shift towards the Warburg effect during fluctuations in oxygen. How do we get fluctuations in oxygen? Hyperglycemia will alter it. Exercise will alter it. Something I haven't talked about yet is sleep apnea. If you suffer from sleep apnea, which in a person who's doing that has breathing irregularities throughout the night, and every time their respiration slows down, this causes oxygen to fluctuate in the circulatory system, which causes the magnitude of the hypoxic environment in the joint to also undergo a fluctuation, which causes the same metabolic shift in the chondrocyte as hyperglycemia. So we move towards this Warburg phenomenon. We have the elevation of acid. We have the elevation of lactate. Both of those get pushed into the extracellular matrix. And what we're going to be talking about shortly is the fact that the acidity increase causes the release of calcium ion, which triggers the seed crystals that are needed to form the crystals of monosodium urate. And then lastly, mechanical shock. So here's the thing about gout. Most people that suffer from gout, and this is epidemiological evidence. So like we know that most people that suffer from gout had a previous injury in the particular joint where the gout happens. And this is not something that's true for everyone, but for a lot of us, it is. In my case, it was for sure. But mechanical shock also induces the chondrocyte to undergo the same metabolic shift that we're talking about, which can cause the release, again, the high lactate, the elevation in hydrogen ion, again, which is going to be causal to the release of calcium, and then the seed crystals of monosodium urate that form. So now, let's go directly to the flare. So one of the first things that all of us need to realize, and I'm going to be talking now heavily about the data from the 60s and the 70s and the 80s, is that when we talk to a doctor about this, and I opened the presentation today with the hypothesis from the medical community, they're like, okay, we have high uric acid, it diffuses into the joint where it crystallizes. This is a sophomore view of solubility from chemistry class, right? And it makes a lot of sense. I can't be overly critical of this. Anyone who's had a basic chemistry class knows that if you take table salt or sugar and you start adding it to a solution, eventually you're going to just see this collapse in crystals. And so it makes sense that doctors would think, well, the uric acid rises in it, solubility point, which is around 6.8 mg per deciliter. Now you're going to get this crystallization. Well, there's a problem with that. And the problem with that is, not unlike most biological compounds that are dissolved in water, the crystallization is not straightforward. And in fact, those guys learned back in the 60s that you could make supersaturated solutions of monosodium urate in water that were stable for months. And in fact, there's one paper that cited that when they set the container away, it was stable for years without forming a crystal. All right. And what they had to do to get the crystallization to happen, which is not unlike a chemistry lab, is they had to add something in order to get the crystallization to collapse and then to form these crystals. So to summarize that data here, we know that monosodium urate is stable in water environments. And in fact, monosodium supersaturated solutions of monosodium urate are super stable as well in the synovial fluid of people that do not suffer from gout. But in a gout sufferer, if you make a supersaturated solution, with their synovial fluid, you can get the monosodium to crystallize. So there is something present in that fluid that has to be present with the with the uric acid, the monosodium urate that's dissolved in order to get it to crystallize. And the list of factors that were required for that are shown on the upper left here of my slide. So number one, you need acidosis. The synovial fluid has to be acidified. And you can get there through exercise. Any of you guys that are athletic like I am know, like if you're doing HIIT exercises and things like that, that you're generating an intermittent hypoxic environment. So I've already laid the groundwork for that. If we have shifts in hypoxia, that's going to alter this environment that's also in the joint. Anytime we have a glycolytic shift away from burning, so incoming glucose that now shifts to being hyperglycemic, then we shift towards Warburg. We have this acidification, down the road we go. Alcohol and lactate contribute to these cellular conditions that will move towards acidosis and can result in formation of seed crystals. So what do we need to have happen directly? So the data from the 60s, 70s, and 80s, when you put it all together, you can break the gout flare into two parts. And this data was really important because basically this is a hypothesis I've been talking about now for 5 years. But it wasn't until I found the data from the guys that I've listed here at the bottom of this slide that we could take the next step forward. So basically what they were able to show is that to get a seed crystal, you need to have this pH decline. You need acidification of the synovial fluid, which can be transient and most likely is. And once that hydrogen ion increases, it causes the release of calcium from the extracellular matrix. There may also be degradation accompanying this, where you have disruption of the proteoglycan network that's there. You can have disruption of the collagen and so on, which most likely is happening in concert with this release in calcium ion. Now, what's the point of the calcium ion? The calcium ion, when you look at the size of the calcium ion, Ca+2, compared to the size of sodium ion, they have nearly the same ionic radius. But calcium ion has twice the charge. And they were able to show, I believe unequivocally, that you have to have calcium ion in order to generate the seed crystals. Once you have those, now the monosodium urate is involved in growth of the crystal. Now, they propose that one of the reasons why people tend to have a singular gout flare relatively earlier in their life, let's say around 50, and then they go decades without it, without any other problems. And this is because having the crystal alone, and there is some data out there to suggest that these seed crystals are protein coated. And there's a lot of argument about what this protein coating is. And I don't know the answer to that, so I don't want to go off on that tangent. Just that these crystals somehow get encapsulated. Doesn't affect the diffusion thing. All it can do is slow the relationship down between something that's crystallized inside this encapsulation and what's going on out here in the free fluid. You slow movement down, but you can't stop diffusion. That's an important concept for later. You can also have, and there's some data for this out there, once the seed crystals are there and they're persisting, then the immune system can get involved in terms of making antibodies. So then you have this setting that is stable for a long period of time, and then there's some kind of an event that happens, and we can have the second phase of this. Keep in mind that these two steps that I'm talking about here also can be simultaneous. So perhaps we don't have the situation like it was with me, but you have one where we get the seed crystals and the conditions are all right to move to the second phase that I'm going to talk about now. And there's no clear answer to where you fall in this continuum. But basically, once we have the seed crystals, there's very strong data that shows that they can interact with the macrophages, the resident innate immune system that is in the joint, present. And the macrophages can interact with these crystals, and the interaction actually activates them. The picture you see on my slide is an actual picture of a macrophage from the work that came out of the 60s. And you can see, or it might have been the 70s here with this one. I don't remember, but it's in those references I have here. You can literally see the monosodium urate crystals that this cell has phagocytized, brought inside. And now that those crystals are in there, these macrophages are activated and start to recruit other innate immune system cells like neutrophils. And in this process, some of these macrophages actually break apart, leaving the crystals that are hyperactivated, right? They're coated with other protein parts and whatnot from the broken up macrophage, which tends to accelerate this whole process. And now you see an elevation of the acidification of the extracellular matrix, the release of more calcium, the influx of the neutrophils, and boom, we have the gout flare. So you can see we have two sides of this thing now to work on. the seed crystals, it is well known now, can persist in joints for decades with no flaring response to those crystals. So it seems like we need some type of an event that's catastrophic that pushes us into this second step. Now, one of the things that I want to quickly cover is what is the evidence for the fructose uric acid metabolism in the chondrocyte. And unfortunately, we don't have any real direct experiments yet. And what I mean by that is we need somebody at the level of tissue culture to really push hard on this and look at being able to block all of the relevant steps in this cascade to unequivocally show that we're activating this pathway. But what do we have? We literally have 10 circumstantial, evidential aspects of the chondrocyte. The first is we know that the polyol pathway is activated in the chondrocyte. This was done in some very elegant studies by the lead author was Laïguian. It was a French lab. Not only do we know that the polyol pathway is activated, but we know that the first and rate-limiting enzyme, aldose reductase, is active in the chondrocyte. We also know that the enzyme for the second step of the polyol, the sorbitol dehydrogenase enzyme, is expressed and active in the chondrocyte. We know from the data I showed you that uric acid, I think it's pretty good data, can be produced in the chondrocyte. And I don't know of another pathway that's producing uric acid in human cells directly. We know that both the key enzymes in the steps to convert adenosine monophosphate, for example, into uric acid are both present there. Xanthine oxidase, xanthine oxidoreductase. And we know we can activate those enzymes in a chondrocyte by putting uric acid in the medium with those cells. So uric acid being able to move into the chondrocyte, activate these enzymes, and then generate more uric acid along with the intracellular effects. We know that there's a glycolytic shift to Warburg. There's evidence for that. We also know that that's true in the macrophage too. So that's another thing to mention here. Everything I'm walking through right now, we know that the macrophage also does it. We know that the chondrocyte has all of the relevant uric acid transporters in it, URAT1 and GLUT9A, for example. We know that uric acid, again, when it's provided in a medium next to cells that are in the joint, it can cause degradation of the extracellular matrix, enzymatic degradation, the expression, release, inducement of proteins like MMP3. I'll talk more about that later. We know the key markers of inflammation, IL-1 beta, the JNK1, which is actually a protein that, among other things, is actually required to get the inflammasome that's hammering our joint. We know the NADPH oxidase, which is a key enzyme in the downregulation of the mitochondria, which is activated and translocated by uric acid, is active in the chondrocyte. And then lastly, we know that in all of these processes together that the chondrocytes can die and rupture. And when you think about that, any uric acid crystallization which can occur inside the chondrocyte is going to be released out into the extracellular matrix, where it will hyperactivate the macrophages that are out there. And this just summarizes what a bigger picture view of what's going on. So one of the things that we know from the osteoarthritis data, of which there are hundreds of papers, is that somebody eating the standard American diet that regularly is going hyperglycemic chronically, day in and day out, along with added sugars and then the alcohol component, which may or may not be in there at the dinner hour as an example, and then also umami, that the chondrocytes are living in an environment where they are under conditions of low-grade inflammation chronically, month in, month out, year after year. And I contend then all we need to do basically, because you have this fundamental environment of inflammation, is provide some sort of key instrumental event, which could be metabolic. It could also be some sort of physical disruption. You know, perhaps somebody stubs their toe like I did on a brick. You just have this event that pushes the chondrocyte over the edge. We get streaming uric acid into the extracellular matrix along with the acidification and the lactate coming in. We get formation of the crystals, and then we can have this vicious cycle that generates the gout flare. All right, now I know I've thrown a lot at you guys. That's the presentation on what I believe causes the gout flare. And what we want to do next is turn to, all right, well, how do we take that information now and apply it to us so that we can prevent flares from happening? Before I do that, does anyone have any questions?
I have lots of questions, but not about that process, because you lost me in a lot of the detail, but I understand the general process now.
All right. Yeah, that's my worry. I know I really went deep with it.
No, and that's all right, but the general idea I get, and
okay.
that's all I really need.
All right. All right, so I'm going to roll faster through this now and try to not get lost in the weeds. So if we just back out of this now and we go, all right, at the core of this, here's the take home I want you to get from what we just talked about. We have a chondrocyte that's most likely chronically inflamed. We have uric acid that either can be produced in that process from the chondrocyte, or it can get there via the circulatory system. So we know that hyperuricemia is in itself not helpful to us. Now, I need to make a differentiation here, because what we know from the 60s and 70s and the 80s is that a fixed average concentration of uric acid in our circulatory system is not the culprit. You guys need to understand that. A fixed average concentration of uric acid is not the culprit. All that stuff I talked about in the weeds, it's going on when we have either sudden acute rises in uric acid or sudden declines. Right, where we now have in the synovial fluid either fluxes that are coming out or fluxes that are coming in that are actively dynamic. That's where we have this arrangement of things that are fluctuating, where we can have those crystals and then the aggravation of the innate immune system that can get to the flare. So the hyperuricemia question, how is it going on? So stepping back, it can happen a couple of different ways. Either via production, which is mainly at the level of the liver, right? This is the big producer. Now, I know I've mentioned, well, we could have some production in the chondrocyte, but the chondrocyte is not the thing that's generating high levels of uric acid into the circulatory system. That's going to be the liver. We can have a substantial amount being generated at the level of the kidney. So it's first liver, second kidney. We also have contributions anywhere else, like from the chondrocyte, perhaps in the brain, adipose and skeletal tissue, but the main producer is the liver. That's the captain. All right. And then the second thing is getting rid of the uric acid is a function of the kidney. Now, some people are going to ask me about, what about the genetics, Dr. Pete? Well, the genetics are complicated, and I think at the level of our establishment, there's this tendency quite often to go, well, there must be a gene for gout. And that's really naive. It isn't. Is it possible that there are genes for gout? Yeah, there are. And every time I get into the literature, I'm blown away by the amount of genes that are involved in this and the different places where the genes exist. Like at the level of the nuclear genome, what's in our nucleus, at the level of the DNA that is in the mitochondria, and then the different levels of genetics. The epigenetic thing, which is how our DNA is packaged in the cell, and how it's packaged is going to reflect which genes are accessible or not. And then at the level of the DNA itself, all right, and then we have this metabolic component. And all three of those things are involved in this. So where the genetics, I think, is having the biggest effect is on the excretion of uric acid at the level of the kidney. And that story is super complex. And I'm not going to try and do it here. We have in the background of all this, all of us probably have a genetic predisposition to gout. Where is that most likely going to have its effect? On the production. Some of us probably hyperproduce the uric acid depending on the metabolics, the hyperglycemia, the added sugar, the alcohol, and the umami. Some of us probably have an issue with that we just make a lot of it. And then some of us, and it could be a combination of both things, we have problems excreting the uric acid at the level we should be based on the production issue. So this is something we have to keep in mind. Now, there is also an intestinal thing, and that has to do with the gut biome. And I'm not even going to try to go there, because one thing that we all know is that the gut biome has a big impact on all of this stuff. But that level of science right now is so complex. I think it would be inappropriate for me to try and even talk about it, other than to say that there are bacteria in our colon that definitely contribute to getting rid of uric acid. But other than saying that, I don't think I can really talk about any more than that. So we can really boil this down right now to production issues and excretion issues. So literally, we reabsorb the vast majority of uric acid that's in our circulatory system. So any kind of interventions that we make on our system, we need to think long-term about it. We want the uric acid to have more time in the circulatory system to get out, right? And that concept, I will talk about a little bit more later when we address urate-lowering drugs. One thing to mention about insulin, hyperinsulinemia seems to cause a decrease in excretion of uric acid. So if we sit back for a minute, we think about what I talked about going on with fructose uric acid in the liver and the generation of hyperinsulinemia and then the insulin resistance. Here you have one of the effects. So right out of the gate, we know we're going to be reaching for that hyperuricemia. We're going to go, you know what? We need to get that down in our lifestyle. All right, I already talked about the diffusion issue. So with hyperuricemia, this is the situation. If we have high uric acid in our circulatory system, then what we're doing is we're fostering the movement of that uric acid into tissues, into the brain, into the kidney, into the synovial fluid of our joints, where that uric acid can diffuse into individual cells and then elicit intracellular effects. This is, again, to remind you that the joint in our toe or our fingers, wherever we have our gout flare, is not the only place where you can have these specialized connective tissue problems where you can have the crystallization of monosodium urate. This just shows you that there are some gout sufferers that actually have crystallization on their heart valves. That's really scary. This just shows you that there's actually a significant amount of data that shows that crystallization of monosodium urate in connective and smooth tissues with these specialized conditions can happen all over your body. Again, we got to pay attention to production, because I think in these specialized connective tissue areas that there is a production issue going on. It does not have to be solely responsible for a gout flare-like event, but I believe we need the specialized conditions for the specific crystallization. And these references is just to point out to you that the data is there that shows that uric acid can indeed diffuse, for example, from the circulatory system into the kidney, where it can elicit, the data is there, where it can elicit the same intracellular systemic inflammation that would happen if the uric acid was otherwise produced directly in that cell. And this just gives you a list of where we know that intracellular effects have been shown unequivocally to happen when we have diffusion of uric acid from outside inside. So the cardiovascular system is a problem, vascular smooth cells, the liver, pancreatic cells, adipose tissue, I believe also in skeletal tissue. Now, if we are going to undergo urate lowering drugs, what's the point? And this is an important aspect of this, because if you go to the doctor for a gout flare, more than likely they're going to say, well, we want to put you on allopurinol, and I'll talk about these drugs coming up, because putting you on allopurinol should stop the gout. That's false. A urate lowering drug is not going to the causative drivers of the gout flare. What it's doing, and this is very important to understand about the laws of diffusion, right? What it's doing is it is instrumentally decreasing the circulatory uric acid to a lower level. And what that does is it forces all of these tissues that have high levels of uric acid because of the diffusion gradient. When uric acid was high in the circulatory system, you flip the gradient. So now the uric acid is going to move from the tissues into the circulatory system. And the more time that the uric acid spends in the circulatory system, the higher the probability over time that you're going to get it excreted out at the level of the kidney. So being on a urate lowering drug can be good for us for this reason. But remember that a gout flare has its highest probability of happening when uric acid in the joint is rising substantially or it's coming down substantially. So when people go on urate lowering drugs, most of the time, most of us will have gout flares. in the process of going on a urate lowering drug. That's an unfortunate aspect of going on urate lowering drugs. And there are other issues too that I will address. Now, how do you decide what the concentration of uric acid ought to be? Well, here's the problem. The medical establishment right now is going to look at what they've done is they look at the average uric acid in our population. And the average uric acid in the United States is between 6 and 7 milligrams per deciliter. But when you look at the early data out of the 1900s, the average uric acid was significantly less than what it is now. In fact, the average adult had uric acid between 3 and 4 mgs per deciliter, 3.5 mgs per deciliter when you track the data down. And so it's my view that if you make the personal choice to go on urate lowering drugs, that you set a target for what the target was or what the average uric acid was in the early 1900s. That's when I was on a urate lowering drug, this is what I did. And I titrated myself very slowly. I got my uric acid literally at this average, and I held ground. Unfortunately for me, I started having side effects due to the allopurinol, which caused arthritis uniformly in my hands, and I had a breakout of rash on my face, and so I stopped the allopurinol. I did that. But I'm letting you know, how do you make these decisions what to do? And I think you have some data. Now, why do people have uric acid these days between 6 and 7? And so far, the arguments for that, in my view, are hand waving, which means that nobody really knows. Most doctors are going to point their fingers. I saw a thing on the TV this morning before the intensive where there was this guy that was going on about, well, we all overeat protein now. And there can be a protein effect. But I just got to tell you right now, when you go out there and you look at the data and you ask the question, is there hard data for how people in the US are eating now compared to the early 1900s? You just don't see this connection with the protein. You don't. What you got are arguments on either side of it with data that's really pretty faulty. What we can say is that there has been an increase in sugar. You can look at that and you can see the correlation, the strong correlation in the data between sugar, obesity, the question of diabetes, and I hate to say it, the rise in gout. And when you overlay the increase in alcohol consumption, you see that line reflected on these other ones. So I don't know why we have a higher uric acid now than we did back then. But if you are thinking about going on a urate lowering drug and you're looking for logic, I think this is a good target. For the reason is we're looking back on a population of people that hadn't been assaulted by the standard American diet yet. And this is what their value was. And that's how I made my decision. Okay, so what do we do now? So for gout remission, and again, I did this starting 5 years ago. My gout's been in remission except when I started messing around with allopurinol. And I had a bunch of flares. And I know we've been at this now almost 2 hours, so I want to be careful here and not go off on tangents. Maybe some of you will have questions about that. But since I've been off allopurinol, I've not suffered any gout flares. And then before that, for 3 years, no gout flares. And then I've had some feedback. I'm not claiming I have something I can write up and send to a peer-reviewed journal. I don't. But the majority of people that are communicating with me now on my YouTube channel are saying they've seen improvements with this, either lower numbers of flares or remission altogether. So I think we're on the right track. So the first thing to do is to eliminate the obvious drivers, and that is to eat in such a way that is no longer hyperglycemia. We know if we let glucose get too high in a meal that we're having, we can open polyol, and when we do that, we're going to open fructose uric acid metabolism. We're going to generate uric acid. Something to keep in mind here is that you can have the gout flare, remember this, without having high uric acid in your circulatory system. So the argument being that you don't have, for some people, not having high uric acid means that they're not opening this pathway. We know that's not true, because some people really are good at excreting uric acid. And so you don't see the spike like you would with me if I did a hyperglycemic meal. So eliminating high glycemic foods, that means the potatoes, the rice, added sugars, processed food. Eliminate its potential here, and this can be touchy ground, that you've got to eliminate alcohol. And I essentially have really cut down on alcohol. I'm not gonna lie to you guys and say that I never have a drink anymore, but I'm just telling you, drinking every day with glucose present, most likely you're going to be flaring, right? The alcohol has an effect, which is factorial. It's not just in the ways that I've talked about, but the intensive would be going on all day long if I really got on a roll about all the effects of alcohol. So you may have to eliminate it altogether. That's possible. The added sugar with the incoming fructose has to be eliminated. And anyone who's suffering from gout should be sleep tested to find out about sleep apnea. Now, this is a relatively fresh area, and most of the data for this, the hypoxia thing, is epidemiological, which I absolutely hate. And I'm not going to be like a lot of people out there and trying to use epidemiological data when it suits me and not when it isn't. So I'm just going to tell you the sleep apnea data is weak, but there's enough epidemiological evidence. And then when you look at the function of the chondrocyte, the fact that it's in a hypoxic environment, and the fact that the metabolic shifts that are happening there, that there's really good data for, are also generated by hypoxia, I'm telling you that I think it's a good idea to get sleep tested. And I live what I ask you guys to do. So when I recently got onto the apnea question, I had myself sleep tested. And indeed, I came back being apnea. And I'm treated now, and I've got my sleep under control, because I don't know about you guys, but I am sick and tired of having my life dogged by metabolic issues. And I felt like, okay, the apnea thing is this loose end sitting out there. I should find out about it. And then if it turns out I am, get treated. And I've done that now. And I feel for the first time in my life that maybe the road I'm on is now the best one, possibly, for long-term health. I think eating a whole real food existence is a really good idea. We're going to talk a little bit about the protein thing. I think most doctors are going to tell you, all right, cut the protein out. No, we don't cut the protein out. Can protein sources cause an increase in uric acid? Of course. But protein modulation is the key here, right? We started out hunter-gatherers, and protein has been a major part of our life all through millions and millions of years. So is protein the problem? Not when you compare it to the major drivers. But don't go out eating, and I'll talk more about this coming up, but don't go out and eat sardines every afternoon, a whole bunch of them, right? That's probably, you see what I mean? It's overeating of certain macronutrients that I think cause the problems here. Now, if you are suffering from other comorbidities besides gout, then you may well have to drop the carbs. That's a fact of life. When you look at all of the data out there for diabetes and so on, the low carb lifestyle is very, very effective at reversing those conditions. And I don't like getting into these diet wars. How you go about this whole real food lifestyle, if you happen to be a plant person, go for it. I don't care what it is. What I'm saying is make sure it's whole real food that you're cutting up and cooking, number one. And number two, eliminate the drivers. That's what you need to do, is get rid of those drivers, right? How you decide to do that is up to you. Now, if you are going lower carb, the amount of ketones is going to matter, because ketones, beta hydroxybutyrate, acetoacetate, when those values rise in your circulatory system, they can have the same effect being excreted into the urine as lactate, which means that you're going to back uric acid up into your circulatory system. So one of the key things with this is keto adaptation. And keto adaptation takes a lot more time than what people say in our own space. You know, the going number is 2 to 3 months, but I'm here to tell you, if you're someone like me who's been on the standard American diet until they were 60 and then did something about it, then keto adaptation took me over a year. And even when you look at the data from Finney and Volek, who have looked at this problem in elite racers, and some people will say, well, Pete, that's an elite athlete. All right, I get that. But even with these elite athletes that are in their 20s and 30s, Finney and Volek are seeing keto adaptation in some of those individuals taking more than 20 months. All told, right? There's different measures. Some of them are faster than others, like glucose. Fasting glucose is going to repair itself. A1C is going to repair itself relatively fast. You know, within a matter of weeks, your fasting glucose is going to look really good. And A1C is only going to be a couple of months. But lipid panel, other markers of this stuff, blood pressure, all that stuff's going to take longer than 2 or 3 months. So again, at the beginning of the talk today, I said, all right, we aren't going to have, you know, our expectations need to be set in the long run. And I think the gout condition that we have in these joints, that specialized set of conditions, we are not going to undo that overnight. This takes a while to do, with just being, you know, careful and being really consistent with our lifestyle. The other stuff I'm going to come back, I already talked about urate lowering strategies. I'm not going to go through one at a time. I put in the Dropbox a list of biomarkers. This is what everybody, like if you listen to Ken Berry, for example, you'll hear a lot. He'll talk about this full list. If you're trying to figure out, okay, I suffer from gout, but are there other problems? Then you probably want to have all this done. If you live in the US, this can be more problematic because you're going to have to pay for it yourself. Most doctors aren't going to want to measure fasting insulin. They're going to argue with you about it because they know they got to get on the phone and argue with the insurance companies. So anyway, I just want you to know this is there if you want to look at it and think about it. The reason for A1C and fructosamine is because fructosamine will give you a better idea if you actually have more sugar in your diet than you think you do. And most people that I work with, they're eating way more sugar in their diet than they think going into this. Almost everybody's going to say, I don't eat sugar anymore. But when you get into the intricacies of how they're eating, it's coming in all different places and they just don't realize it. This is somewhat controversial. There are biomarkers that you can measure yourself. And I regularly look at my fasting glucose, my ketones. I measure my uric acid. I put the links to these meters. It's also in the Dropbox. And recently I've been messing with lactate. Now, I'm not advocating that you got to go out and get a lactate meter. It's super expensive, number one. But the reason I'm looking at it is because lactate is a signaling molecule like uric acid. It's involved in energetics. It is a substrate our cells use to generate energy, and also acetate. So I don't know, I put a picture of it here. I don't do this stuff every single morning, but I do N1 on myself, in part because I want to be able to help you guys better. And I'm tracking lactate heavily in my exercise regime and looking what happens on rest days and with the uric acid and whatnot. So anyway, my point here is that you can track weight, you can track blood pressure, fasting glucose, ketones, uric acid, and if you want, you can go after the lactate too. And this is very powerful in terms of the glucose and the ketones and the uric acid, because these meters allow you to also test the foods that you're eating, right? You can take your glucose, ketones, and uric acid before and after a meal, and you can see what that liver production issue is. And it allows you to make intelligent decisions about what you're eating. Remember, remission is long-term, and getting keto adapted takes a long time. What I tell everyone is that get yourself in remission first, and then consider urate lowering drugs later. And be patient. I work with a lot of people that when I first start working with them, they're doing everything at once. They've got a crap load of supplements. They're on urate lowering that they just started yesterday. They're going ketogenic or carnivore. All of this started yesterday. And metabolically, they're a train wreck. And when something happens 2 days later, like they're flaring like crazy, you can't sort out what's going on. It's impossible. So the key thing is to get remission, the eating lifestyle first, and then incrementally start these other things one at a time. Because that way, when something happens, like in my case with allopurinol, it's like, all right, I didn't have this finger arthritis until I started taking this. So I stop it. 2 days later, no arthritis. All right, I know what the problem was, right? So it's that kind of thinking going forward. This was the argument for urate lowering, to switch that gradient. If you're going to go on a urate lowering drug, this is a very personal decision. Before the intensive today, I went back and reviewed everything I could find out about the key drugs, and all of them are scary. They all have scary side effects. Do you want to do it? I don't know. You got to decide that and then talk to your doctor. If you do decide to do it, I recommend titrating. What does that mean in English? Don't start with a maximum dose. Convince your doctor, we're going to do this incrementally. Start with the lowest dose you can get. Spend a few weeks, see what happens, and then systematically move up to a target. And you decide what the target is. I would not, I have some extended family here, friends, who set the target at 6 and 7 mg per deciliter. And I'm going, what's the point of that? That's our whole culture. So I'm like, set the target where we know in the early 1900s that the average was, right? And use that, or you come up with your own rationale. But before you go on the drug, think about where you want to get with it. Because remember, urate lowering drugs are not directed at stopping gout. It's not causal. Uric acid is not causing gout. It's uric acid plus the set of conditions that can lead to gout. And that drug is not downregulating those conditions. It's lowering the uric acid. And when I went on allopurinol, I experienced a whole number of flares. It wasn't just one. And my flares were happening with uric acid at 4.5 mg per deciliter. So if you do go on a urate lowering drug, just be aware you probably are going to be flaring, and you want to have anti-inflammatories available if that happens. Now, a lot of people ask me about supplements, and I've tested all these in N1. Quercetin definitely works. But remember that allopurinol, and also when I'm talking a lot, I always mispronounce this drug, febuxostat. Both of those are inhibiting the main enzymes in the liver that produce uric acid, xanthine oxidase. And quercetin does exactly the same thing. So here is the issue. We know that xanthine and hypoxanthine, these are the side products that get backed up when you inhibit xanthine oxidase in the liver. So my point is, the side products that in the production of uric acid get backed up in the liver, and then those are going to get pushed into the circulatory system, where they can make their way to the kidneys where they're going to be excreted, or they can diffuse into your joint. And one of the key experiments that they did in the 60s, 70s, and the 80s was they showed that crystalline, xanthine, and hypoxanthine can, I think you guys are guessing where I'm going with this, cause a gout flare. And it is not known. This is another potential reason why a urate lowering drug might be causing you to flare, because of the production of these side products that end up in the circulatory system that now your body is contending with. So again, if you're going to go the route of the supplement, and a lot of people do, just be careful with it. And again, the rule of thumb is to start low and move up. Monitor your uric acid yourself using a handheld meter, and be cognizant of any sudden onset of other symptoms, because they could happen with this. Tart cherry also works to lower circulating uric acid, but it's not as effective as quercetin. You also can attack the excretion issue at the level of the kidney. And the way to do that is through potassium citrate. This is one source, ketocitrate, that there's a company, Santa Barbara Nutrients, is producing. It's effective. I've tried it. It works, but it's very expensive, $121 a month. You also can get potassium citrate yourself from bulk supplements. Very inexpensive, but use it carefully. Measure your urine pH. Don't go buttloads on this. So follow the directions for it off the package. Start low. You can move up. And I recommend looking for a urine pH between 6 and 6.5. And the literature suggests that this works best in combination with a urate lowering drug. This is the only mitochondrial supplement that I've tried and thought, this is anecdotal, and thought that I felt an improvement in my recovery during exercise. Remember, all these slide decks are in my Dropbox. All right, so let's cut to this. Now, this is another aspect of which there's a lot of literature going back on gout. Amazingly long. I mean, I had no idea we knew this much about gout. This slide comes from the mid 1800s, 1849, and these guys already knew what lifestyles tended to work for their patients and what things didn't. And look at this. What they found was best was a mixture of animal protein and vegetable food. Basically, we're looking at an Atkins diet here, right? This is where I start with this. Mm-hmm. They knew that the milk diets and purine diets, these excruciating things where you're not having any protein at all, pure vegetable diets, and look, starch diets, right? They don't work. Why? Because hyperglycemia, that's one of the drivers. Mm-hmm. So if you're eating stuff that's super high in glucose, you're activating polyol and you're getting the fructose uric acid pathway going on. And we know hyperglycemia irritates chondrocytes. It causes, like I said, there's a ton of osteoarthritis data. They know hyperglycemia puts the chondrocyte into a state of low-grade inflammation, right? And if we're doing that, there's probably intracellular uric acid being generated. I gave you guys all the evidence for fructose uric acid in there. And if we're doing that, then we have conditions that are on their way to generate a crystal and get on that pathway for the gout flare. So again, I've already talked about this, but I want to emphasize the fact. What do? We eliminate the hyperglycemia, the added sugar, processed foods that bring in not only added sugar, but also umami, high glutamate, right? They put seasoning in there in processed food that is like monosodium glutamate. They've learned that the public is sensitive to MSG. So what do? They put yeast extract in the processed food instead, because they know that the public won't recognize that when they read the ingredient list in a box of macaroni and noodles, right? Okay, what else? Oh, fruit juices, just as bad as soda. What are you doing with that? You're delivering a high load of added sugar that has high fructose in it to the liver in a short period of time. Boom. Activation of fructose uric acid metabolism, sports drinks, protein drinks, all of that stuff. Most of the time, if you look at the ingredient list carefully, is going to have large loads of carbohydrates in them. And we don't want the hyperglycemia again. Hyperglycemia plays a big part in this. And then we're eliminating all proteins of all types, rice of all types, grains, and added sugars. This is just an example of my 30-day menu. It's just showing 7 days. And you can see the way that I eat. Now, going back to the very beginning of this presentation, I'm just going to tell you guys from a coaching point of view, I've really gotten some pushback here. And one of the pushbacks have been, with individuals, I understand where they're coming from. They're like, dude, I'm working 16 hours a day at my job. I don't have the time to cook. I just want to eat out. That's all I want to do. Now, I'm letting you guys know, this is a situation where the food plan, honestly, has to be put first. Because if you don't put it first, then your sickness is going to continue to get worse. And if it gets worse, you can't do the job that you love so much. Your family life is going to suffer. That's important. Whatever that is. Your social life is going to suffer. Why? Because you're not going to be there. You're going to be limping around. I've got some clients literally that are on walkers because of their gout, that now have been able to put the walker in the closet. But that isn't going to happen unless you're willing to go, okay, you know what? I got to sit back and realize that I need to eat to live, versus flipping this around and going, I'm living to eat, right? Hopefully you guys see the difference. So I went through it too. I mean, I'm just like you guys. I went through this. There was a time frame where I'm like, this is really a pain in the neck. I can't believe I've got to focus so much on this. But now my gout's in remission and my diabetes is a thing of history. And I'm doing things I'm going to be 65 in 2 months, and I'm doing things that I haven't been able to do since I was in my 30s. So it's like, okay, come on. All right. Yes. On one level, it's a sacrifice, but it won't last that long. Pretty soon, this is just going to be second nature if you give it a chance. So basically, and everyone has different ways that they do this. There's some people that they cook on Sundays and they put everything in a container in their refrigerator. But basically, I just make sure that when I cook dinner in the evening, I always over make all the food that I'm having. And so in the refrigerator, I have leftovers all the time. And on days when I'm super busy and I got to leave my house at, 7 a.m., I just reach in the refrigerator and I just take a container and I put my leftovers in there and I'm good to go for the day. And, once you start to do this and you see your health improving and you see the gout becoming a thing of the past and your other markers getting better and you feel better, you have more energy and everything. It's like, now I can't even conceive to going back to the way I used to eat. This is in the Dropbox. All right, now, there's going to be lots of people out there. I've already let the cat out of the bag. I pretty much subscribe to Atkins. And that's what really everyone's doing. It's just whether or not you're more extreme with this. And there are some people that want to go out and they want to count calories and, they're using these apps and everything like that. You don't need to do any of that. This is really simple. If you imagine metaphorically a plate, and the plate's just going to be split into 3 parts. 2 of the parts have green listed vegetables in them. I've got roasted Brussels sprouts here and some broccoli. And you can look at the green listed vegetables. There's lots of different options on there. I've learned how to roast vegetables. They're really, really good that way. And then you've got one portion of the plate that is going to have protein on it. And there are some discussions about, all right, well, how do you decide about how much protein? And I elect, you have to start somewhere. So the way I think about this is the fat wallet that goes in the back pocket of a man, right? You're like, how does that guy get all of that wallet into that pocket? That's how much protein I have on my plate. But, depending on your activity level, you may actually want more. And I'll give you some ways that you can figure that out. Here are some examples of what I eat. Now, on the left side at the top, you can see I have 3 fried eggs there on a bed of liver. Now, you're probably going, but Pete, liver's got a lot of purines in it. Of course. How often do I eat liver? Not very often. But I'm not telling you can't ever have it. That's the thing about this. With the protein, I'm very careful and I modulate it. I try not to have the same kind of protein every single day, day in and day out. And the case with high purine proteins, I seldom have them, but I don't not eat them. So I might have a couple of oysters, but you better not sit down and just go gung-ho on them. Same thing goes with sardines or anchovies. It's not that I never have them, but I just limit them in my lifestyle. As for other proteins, I try to have different proteins every day. Chicken one day, a pork of some type maybe on another day, beef on another day. I had a carnivore recently who who talked to me about they were flaring. And when I started asking carefully, and this is pretty typical, I think, of carnivores, they tend to get on one type of a protein, right? And I think this one was ribeye steaks every day for dinner. So I was like, let's modulate this. Don't have the ribeye every single night. Maybe have it once a week, and then insert these other proteins. And when that happened, then the flaring seemed to recede, right? Our bodies seem to be able to respond to different kinds of proteins different ways. And remember that all protein has got glutamate in it, and glutamate will activate this pathway. But, there's this digestive process and how we process this stuff. So you may have to tweak that around a little bit. Now, on the top of this, I've got my breakfast going all the way across there. There's omelets that you can do. I just make sure the one on the right with the sausage patties, I make sure to use high-fat sour cream there that doesn't have any more than 1 gram of carb per serving in it. The sausage is, and I'm making a point here, is that I did not buy that sausage in a food chain supermarket, right? Because you won't find sausage in places like that don't have sugar and other crap, MSG in them, and that whole 9 yards. I buy my sausage from a guy here in Phoenix who makes it from scratch. And so the sourcing is done carefully. The sausage that I eat is really clean. There's no sugar in it or any of the other business. It doesn't spike my uric acid, and it doesn't spike my glucose. Down below, you can see there's a typical plate for dinner on the left. I've got fried chicken there, roasted yellow squash, and I've got some Asian eggplant. There's a pizza on there. It's chicken crust. And I use some homemade sausage, again, from the same place where I bought the breakfast sausage. It's really, really super clean. This was an excellent meal. There's no tomato sauce on it from the supermarket. This stuff, I just put some cut up tomatoes on it. It doesn't spike glucose. It doesn't spike my uric acid significantly. And it was a great meal. My point is, this lifestyle is super diverse. The only thing limiting it is creativity, right? And it takes a little bit of time to learning how to cook this way versus the days when, I was throwing down on a ton of carbs on the plate and so on. This is just more examples. Up and left there with all the basil leaves. This is a Thai chili curry dish that I made from scratch. It's only got heavy cream in it. Carbs are super low. There aren't any, basically. It's really tasty, as good as anything you're going to have in a Thai restaurant, except there's no sugar in it, any of the other business. And then I've got down on the right there, I have a ground chicken soup that I make. There's no MSG in it. There's not, again, it's really clean. It doesn't spike my markers. And the good thing about making soups is that you've got food for several days, at least 2 dinners, and there's stuff there if you're going to have a lunch. This is just to indicate the sheer number of vegetables. And if you look in the drop box, there's green listed vegetables there. You'll find more stuff. A word about the fats. I believe it's best to eat a wide variety of them. And I've listed the natural ones in yellow. Notice that people in our space tend to talk about these fats as if they're all of one type, like ghee. You'll see that not only is there saturated fat in it, but also monounsaturated fats and a little bit of polyunsaturated fats. So none of these natural fats are just one way or the other. Sure, they've got more of one type of specific fat in them usually than the other types, which you are getting different ones. And the other thing that I try to really do is to use a wide variety of them and not eat just one type of fat, right? Again, what we're trying to do is balance this out. We just want to not have the drivers of gout in there. And then at the bottom, I put the soybean oil because we want to avoid the highly refined seed oils. This is the one thing that I agree with our space on. Those should be eliminated from what it is we're eating. What we want is natural, unrefined oils and maintain a variety of them. Now on the protein, this is an iffy thing because we do know from a cultural point of view that especially if you're an older individual, we should be eating more protein than we are. And I'm going to be, like I said, 65 in 2 months. And I'm an athlete. So I'm doing high intensity stuff anywhere from 5 to 7 days a week because I also am a rock climber. So like I have rest days, but on some days it's just what I call a movement day. So bottom line is I need more protein than what is subscribed in these lifestyles. And I've adjusted how much protein I eat. And how did I do that? I based on how I feel, how quickly I recover, how do I feel on the days that I have recovered doing the things that I do. So where do you start? Here are 2 methods. Again, the slide deck is in the Dropbox and you can look at this. I honestly feel no matter which method you use here, you can see you end up basically at the same place. 19 ounces, I think, for this example, which should be, I think I use me as the example because I weigh 134 right now. Anyway, what is my point? I think this is a starting place. And how do you decide? Well, I'm saying you're probably going to go up from here, is most likely the situation. And the more active that you are, the better that you have with your stress levels, the better you have with your sleep index and all that kind of business, then you can figure out, okay, I need to move my protein up. And so I recommend if you need a place to start, you can calculate it this way. And then from there, though, I think based on activity level, you'll probably be moving up. At least that's what happened with me. And I would say I'm probably at this point somewhere around 23 ounces a day on total protein. Oh, this is just to emphasize. So I'm just going to go through this really fast. I don't care where you sit on any of this stuff. Processed dressings are one of the worst offenders that you can even imagine. The amount of sugar, the glutamate containing additives like MSG, all that stuff, these are really, really bad. I have this on here because there are family members, extended family members that buy this stuff by the gallons. And the content of the hyperglycemia and the added sugar bringing in the fructose is substantial here. So there is no such thing as a good fruit juice. This is just reminding you about sodas. And on the right is a sports drink. At least it's marketed as one. It's got like 63 grams of refined sugar in it. I mean, you're probably going to flare if you're eating this kind of stuff. Typical day, I usually have 3 cups of coffee. I'm currently debating whether I'm going to keep drinking coffee or not. And then usually I have my first meal between 9 a.m. and 10 a.m. With my athleticism right now, I'm actually eating a smaller meal about mid-afternoon, structured exactly the same way. There's no snacking. And then you're looking at my dinner at the bottom of that. slides. So I have what I call my Bamo salad over there on the right. And then you can see my dish on the left. Again, it looks just like what I partitioned. There's protein, 2 green listed vegetables. That's typical dinner meal for me. And then no snacking. All right. Modulating sleep is important. I'm not one of those guys going to tell you have to have 8 hours. I mean, we're all individuals. We're all different, but you need to take a look at that. If you haven't been tested for sleep apnea and you are a gout sufferer, get tested and find out. It's worth it. Biomarkers, I routinely look at weight, blood pressure, fasting glucose, ketones, uric acid, and lately I've been messing with the lactate. Meal timing, it matters, especially the last meal of the day should be earlier in the day rather than later. So eating late in the evening is not a good idea. There's a direct correlation with that and elevated uric acid in the morning. And that's anecdotal. That comes from 5 years of testing on my part. So I try to have my dinner meal done by 6 p.m. That seems to work pretty good for me. And it allows me to get along with my wife, who would prefer to eat later. So, yeah. If I eat later than that, like 7 or 8, sometimes life happens, whatever. But if I measure my uric acid in the morning, these days I spot check, it's always going to be higher than if I'd eaten earlier. And uric acid, by the way, is diurnal. It's always higher in the morning and lowest in the late afternoon. That's natural. And nitric oxide is the inverse of that. So the nitric oxide, which is really important to us, is usually lowest in the morning and highest in the late afternoon. There's a relationship between circulating uric acid and nitric oxide. All right. And it's worth mentioning that there is a relationship between hyperuricemia and erectile dysfunction. So getting uric acid down, right? Doing it holistically the way that we're talking about it, generally speaking, the other issue should improve, right? But if you're thinking about urate lowering drugs, this could also be another reason why you would be considering it. But I don't want to beat a dead horse with that. Not everyone's comfortable talking about that potential issue. Not everybody has it. But as a side note, when you listen to these guys talking about the main influencers out there talking about low carb and reversal of diabetes and the improvement in cardiovascular disease, oftentimes they will bring up erectile dysfunction as a function of insulin resistance. And now you know the reason, because fructose uric acid is driving the uric acid, which is driving, it's one of the central driving factors of insulin resistance. And uric acid has an inverse relationship with nitric oxide, and nitric oxide is fundamental in erectile function. Okay, restaurants, whether we want to admit it or not, are processed food. The question is, how good is the restaurant, right? So one thing, the key thing that I recommend is that I usually will know before I go to a restaurant which one it is. And today in the internet, you can get the menu, usually, not all the time, but usually. And I recommend doing that and looking at the menu to see what's going to be safe on there. Because even with meat, a lot of times these guys will put sauces on there, and the sauces will have added sugar in it. It may have MSG. I mean, there's just a lot of things that they do on top of using seed oils to cook everything. So if you look at a menu in advance, usually you can figure out what you're going to be able to eat there. And I'm not saying you can't go to restaurants. I do it with my wife. We meet socially with friends of ours and family, all that kind of thing. But I always look at the menu in advance. And occasionally, this is pretty rare, but occasionally I'll look at a menu and go, oh my God, there is really nothing that I can eat on this menu. And in those cases, what I'll do is propose to the group that we go to a different restaurant. And, if there's a lot of objection to it, then I will eat before I go. And I'm not going to sit there and not eat anything. But usually you can figure out something on that menu so it looks like you're eating while the rest of them are eating. So in any case, I think you have to be careful about restaurants. And ordering a la carte is a good way to go on it. Avoid sauces. And you may have to ask questions, which this is always awkward. I'm not going to pretend like it isn't. I always feel like I'm that guy, oh my God, I've got to ask the waiter. But so, it's one of those hurdles that you just kind of got to get over. And I'm not saying it's easy to do that. Everyone's got their own way of working. If you've already looked at the menu on the internet, you might not have to have the conversation at all, but maybe you still do. And just want to think in advance how to have the conversation. I would argue, don't be afraid to just ask. And then with meat, almost always they're going to want to put potatoes on the plate. So I usually ask if they can switch out grilled vegetables, something like that. Usually they're okay with that. Sometimes you may have an issue. Like one time I had a chef actually come out of the kitchen and lecture me that with his meat, you could not eat it unless you also had the potato. And I was like, you know what? Bring it with the potato. I just won't eat the potato. So I don't know. That's only like one time out of the last 5 years. So, okay. If we're keto adapted, my ketones range between 0.5 and 1 is where I've landed. And I think, honestly, for a gout sufferer, this is the best place to be. Because between 0.5 and 1, this is anecdotal, but between 0.5 and 1, I don't see that relationship between the excretion phenomenon of the ketones and the uric acid. Remember what I said. If ketones rise high, which they do when somebody in the beginning goes on a ketogenic diet, right? Usually they see their ketones really come up if they're doing a good job with this. And they can range anywhere from 2 to 5. Well, I have found that if your ketones are much above 1, then the excretion phenomenon at the kidney tends to back the uric acid up. But as long as I am between 0.5 and 1, I've got nice ketones in my system. I know I'm keeping my carbs low enough for my lifestyle, but my ketones aren't high enough that they're causing an issue with the uric acid. And one of the key things to remember about this is that beta hydroxybutyrate actually inhibits the gout flare inflammasome. It actually inhibits it. So being keto adapted is good. But not running ketones so high that you're causing spikes in uric acid, which are shifting, up and then having to come down. Somebody always asks me about exogenous ketones too. And I'm experimenting with that right now because of my athleticism for different reasons than what I'm talking about here. So if someone wants to ask about this a little bit later, we can do that. But for the keto adaptation process, exogenous ketones are not helping you. So forget about that. The other issue is bringing them in can complicate the issue we have with letting ketones getting too high, and then you start backing the uric acid up. So get keto adapted first. If you're an athlete, you may want to supplement but for other reasons. And I can talk about how to do that, the best way to do that without mucking up what we're talking about here. Okay, again, I already talked about biomarker monitoring. Okay, so once we get keto adapted, one of the big questions is the urate lowering drug issue. So gout loves inconsistency. And what do I mean by that? I think that uric acid is really fundamental to our biology. I think that it is involved like lactate and acetate. I think it evolved a function where it is a nutrient sensor. This is what I think. I have no data for it. And one of its primary functions is to alert our tissues when certain macronutrients are coming in, glucose at a high level, fructose, and also fats. And the reason why it's a nutrient sensor is to elicit a change in programming at the level of the liver and the kidneys and in the brain, so that the system knows, okay, everything coming in now, number one, needs to be stored. We need our fat stored away. We need the glycogen topped off. There are proteins that are elevated, like mTOR, in this process, whose function it is to go, all right, dudes, it's time to rebuild. So we're in this mode, like in the chondrocyte, where the joint should be undergoing some fluctuations in the integrity of the things that needed to be done, right? And the uric acid, I believe, is involved in the signaling process. But where we get into trouble is when the loads get too high, to the point now where our unified system, if you will, is going, oh man, there's way too much of this. What are we going to do with it? So it starts to precipitate it into the solid, where it can be pushed away or put into a situation where it can no longer have this instantaneous dynamic, where it's in equilibrium with the concentration, the circulating concentration of it. I don't know if this is true or not. This is the way I think about it. So the reason why we flare is when we have sudden increases or sudden decreases in the flux of this molecule. So the key with it is to get into gout remission and stay there, right? We hear a lot out there about, well, I want to have at least one cheat day a week, or I want to have this, or I want to have that, in order to try to get our lifestyle back the way it was. Well, I think if we do that, you're just asking for it. And that's why I brought up the issue of alcohol. I get asked that question a lot on my YouTube channel. And I was a drinker. I still have an occasional drink. But I know every single time I take that occasional drink that I am risking a flare. So, and the reason I am is because I know, and alcohol has a profound effect. If you're a drinker, you can actually test this yourself with your uric acid meter. You can test your blood before you have the drink. Then you can test it after the drink. And you can see the uric acid come up. It's clear cut. I've seen my uric acid come up 4 mg per deciliter. The change in that much of it go from 7 to 8 to 12. That was 5 years ago when I was looking at stuff like that. So in that fluctuation is where the problem is. And so anyway, my point is, make a plan, stick to the plan. Not everybody is going to have the same sensitivity to hyperglycemia, to the added sugar, to the alcohol, and to the umami. All the same. You're going to need to sort out where you fall in that. Some people, I think, are going to be hypersensitive to the alcohol. And those that are may well be also hypersensitive to the hyperglycemia, because they work in concert with one another to open that pathway. You got to sort it out. So my belief is that getting keto adapted first, or really situated in the whole food lifestyle, if that's the level that you want to go to, getting the flares as a thing of past. And then if you're going to experiment, but be very careful with it, because I think our lifestyle is for life. This is not, okay, I'm on my lifestyle 6 months from now, no more fatty liver, I'm cured. No, we have a predisposition to these conditions. So we want to get stable and then hold our ground there. This is why doctors who are really good in our area, like Johnson, and there are others, will tell you, if you go on allopurinol or a urate lowering drug, you should stay on it the rest of your life. Now, I wanted to do that, but I had the side effects. So it was like, I'm going to let it go. And I may well go on another urate lowering drug, because my average uric acid right now fluctuates between 5.6, and I think this morning I was 7.6 or 7.7. And I don't like that. That fluctuation, I'm not sure exactly. I was trying to think this morning why I was at 7.7. I don't know right now. But anyway, my point is, I think I would rather be between 3 and 4 like I was before. But I'm not sure there's a drug out there that's not going to cause side effects. So get keto adapted. Take a good look at your uricemia. If you're still hyperuricemic, and I'm talking about taking a lot of time for this. This is not like a week or 2 weeks. This is getting keto adapted. I think I spent 3 years before I considered urate lowering. Then I considered urate lowering. I went one step at a time. I titrated. And here you can see that when I was on a urate lowering drug, this is my data. So up there at the top, the purple, that's what my uric acid was before keto adaptation in the early years of starting a ketogenic lifestyle. The black is where I was after keto adapted. So this was a 3-year process, I think, right? Let's see, 19, 20, 21. Yeah. And then the light green down there at the bottom is when I went in 2022, when I started allopurinol and went on a target. So the red, I had targeted between 5 and 6. The green, I targeted at 3.5. And then what's not showing here is where I am now, because I got hit with those side effects. No gout flares until I went on allopurinol. And then I had a bunch. Okay, so the question is, exercise is super important for us. This comes up because people will ask me, isn't uric acid going to rise with exercise? Of course. I mean, because if you're exercising, you're going to be causing your muscles to adapt. And when muscle tissue gets damaged, it has to get broken down and then resynthesized. When you break it down, you're going to break down stuff that has purines in it. You're going to see the uric acid go up. Now, I've tested this rigorously. I've tested my uric acid before strength training and after the training event. I've tested it before high intensity HIIT exercises and after. I've tested it before going out and doing a climbing session in the gyms or outside, and then when I got home, and you see uric acid rise post exercise in all of those events. High intensity exercise increases it the most, and then it falls. Strength training, it raises it to the next degree, and then it falls. And then regular exercise causes it to increase, and then it falls. So don't forget, it's my belief that uric acid is required on a functional level in our biology. I think it's a nutrient sensor, and I think it's talking to cells about what type of programming those cells should be in. Are we fixing something? Are we remaking? Or are we in, the burning mode? Lustig talks about this type of programming a lot in his book, Metabolical. And while he doesn't talk about uric acid, when I read Metabolical, I see the connections between the enzymatic cascades he's talking about and the integration of this metabolism that I've been trying to teach you guys for the last couple of hours. This stuff is not unconnected. It's all connected. And the question is, which format is our cellular network in, right? And fructose uric acid metabolism has a profound effect on pushing us into a storage rebuilding mode. That's my belief about it. The problem becomes when we chronically are pushing these systems to be in that mode all the time. We're not supposed to be that way, right? We're supposed to be in the burning mode most of the time, and then we're supposed to shift out of that mode when we're eating and when we're building. The post-eating thing when we're building back, and then moving back into the burning mode. So the exercise is really important because of the increased capillarity, the fact that it increases the efficiency of our heart. Like my resting heart rate now that I measure daily is between 51 to 54. Muscle tissue is optimized and built up, right? I'm almost 65, right? And if you look at the progression of strength, power, balance, all that stuff, in the progression of age with somebody who's inactive, when they reach the age of 70 years old, they've lost about half of all of it. Their strength. Power is the ability to pick up a box of books and move it quickly. That's power. The strength is just to be able to pick the box up, basically, right? And then the balance and all that. You might be wondering, what does all this have to do with gout? Well, it has a big thing to do with gout because our metabolism, our ability to deal with these metabolic shifts is better the fitter we are and the better our circulation is in regard to everything that involves this circulation of uric acid. So just because uric acid rises with exercise, that's true with everybody. I think all we're following there is the natural rise and fall of this really important biological molecule. What we need to eliminate are these really strong dynamic shifts that are happening and the chronic establishment of this metabolic these metabolic pathways in a place where they should not be statically. They should only be, those pathways should exist dynamically. Okay, and I'm just going to step out here. I think in terms of the exercise issue that you really need what I call 3 areas pretty much. I know I have 4 on the slide, but activity, and movement are all basically one thing, something that you love to do. I don't care what it is, but it gets you moving around. And then all of us should have strength training where you're picking up heavy objects. We need the muscle mass, right? The muscle is the biggest operational modulator of glucose we have in our system. And it has a profound effect on the relationship with insulin, for example. And we know that insulin is also tightly coupled to what's going on with uric acid in the liver. So these things are all really important. And then high intensity, we need to be elevating our heart rate frequently over the course of a week. I shouldn't have used the word frequently. This needs to be done a day or two a week for a short period of time. And then there's the issue of stress. I've been asked a lot, well, don't you think cortisol is involved with uric acid? Yeah, I do. Do I know what it is exactly? No, but I know enough to know that these pathways that I described to you cannot be disconnected from cortisol. Cortisol has a profound effect on insulin. We know that modulation of glucose and hyperglycemia and added sugar with the fructose and these umami foods are altering the state of the liver, just as the core example. And so this can't be happening independent. So whatever lifestyle that we go down to put gout in remission, we need to consider the stress that we have in our lives and start operating to modulate that, or, to do something about it, whatever those things might be in our own personal lives, whether it be relationships, work relationships, work situations, and those things. It is important for us to think about the eating lifestyle first and getting that under control, getting keto adapted. And then remember, all these things are incremental. And I've addressed all of this stuff intuitively. I feel like, all right, I've got one thing going on that looks good. Now, what's the next thing that I can do, and so on. And sleep is a factor. The big part here is not suffering from sleep apnea, because it's causing your body to roll through these episodes where you have low delivery of oxygen, partial pressure of oxygen to multiple organs. And if you think about it, all of our organs have hypoxic zones in them. A liver human's pretty big. Human liver is pretty big. Same with the kidneys, and the kidneys have definitely got a hypoxic zone there. There's a big difference between the medulla and the cortex. And we know that this hypoxic zone exists in our joints, for example. All of the big organs have hypoxic zones where the capillaries meet the tissue. Then oxygen has to diffuse all the way in and all the way through. So in the case of sleep apnea, where we have zones of oxygen going low, that's going to cause these magnitudes to shift in our organs intermittently all night long. And every time you get this shift, we know that those organs are shifting metabolically towards Warburg and the same state of affairs that we have in fructose uric acid. So if you haven't been tested, I think it's a loose end. You should have it looked at. I know everyone waves their hands about that. Most doctors, I know mine was like, you what? You don't need to do that. Then it turned out when I was sleep tested that I actually was apnea. I could see the results myself. I don't ever ask a doctor for anything anymore without seeing the data myself and looking at it. I mean, if there's an overarching take home here of this whole thing, it's taking control of your health yourself so that you can do something about it, because metabolic diseases like gout, as to steal a term from Lustig, they're not druggable. There is no drug for gout right now, right? because we don't really understand the direct cause of it. We know uric acid's involved in it. If we can get the uric acid under control, that should help us, but it may not be the end result. Okay. So that's put us at about 3 hours now. You guys are probably exhausted. And I've finished the presentations. What I want to do now, if you guys want to take a breath, is we can field questions.
It sounds good.
Thanks, Dr. Pete. I don't get gout in one joint, but each day it can appear in a different joint when I'm having a flare-up.
It can be in different joints.
Yes.
That's not uncommon.
Okay.
It's not uncommon. I mean, a doctor's going to tell you that it isn't, but you're describing something I've seen with clients. Now, we don't really know why that's happening. I think, and there's no data for this, but I think that as time goes on, we're going to find out there's more crystals involved in this than just monosodium urate. Okay. I think calcium pyrophosphate, there is data for that in some people, when they have aspirated crystals, synovial fluid, that they've found the presence of both of those crystals. Now, nobody really understands how that could be happening. And the main establishment pushes back on that. They're like, no, if it's gout, it's just monosodium. But they're ignoring 3 decades worth of work out of the 60s, 70s, and 80s. And I told you that story. One of the crystal mixtures that got injected into joints, into their own joints, was calcium crystals, pyrophosphate. I think that was the correct calcium crystal. And believe it or not, creatine phosphate crystals. And they all elicited gout symptoms. So why is that a factor potentially for you? And unfortunately, when I think about what we talked about today, I don't have any direct. I think that the drivers for this are the same core metabolic pathway, but I don't yet feel like I understand enough about the calcium pyrophosphate part of this to tell you this. But I think for people where it's shifting around, that you're not dealing with just monosodium urate. I think you are also dealing with a calcium oriented crystal, which you may not be really amazingly helpful to you. But I feel like eliminating those drivers that we're talking about, I still think it's the same core pathway, but with nuances. Yeah. And nobody knows what the nuances are. I have no idea.
But to know that it's not unique, that it isn't a common thing, that's important for me.
Yeah.
To know that it's not all in the head.
I've worked with a couple clients. I worked with a client who, when they flare in both knees at the same time. And the doctor is adamant, this is gout, but we don't know how to explain it. And I'm saying, I think it's calcium and monosodium urate. And I'm working with a client right now, for example, that has gout. When they have gout, it seems to be in the big joint of the toe, in the ankle on the same foot, and on the knee of the same foot. And I think it's calcium. I think they're seeing a combination there that when it arises is because it's symptomatically, it doesn't look like the classic one joint gout hit.
Yeah, I can confirm that actually because it does move around, the same starting toe, goes to knees, little fingers, and so on. There's not only one joint; it moves around and
in different joints.
yes,
Which is really annoying.
yes, very annoying. Yes,
Mine's all in the foot though, in different joints in the foot.
in the foot, yeah,
in
same
in the
foot,
bones,
but
different
the
bones
toe,
Different
or let's
joints.
say starting in the knee, then going the toe, little finger, side of the foot, like that. Yeah. Then of course it disappears by itself. Till the next. You can hear me, yeah?
Yes.
Yes.
I'm making some notes.
Now, is uric acid
Can you
stored anywhere
elaborate
in the body?
on this?
Sorry,
Hello?
go ahead, Nancy.
Can you
Jack,
elaborate more on this?
Okay, go ahead,
Can you-
Hassan.
Elaborate more on this uric acid and nitric oxide relationship. I mean,
Which, can you say that again? Let me turn this up.
between uric acid and nitric oxide relationship itself. How is it?
Okay, so when uric acid acutely rises in the liver, it causes in the liver the downregulation of nitric oxide pathway. Now, the endothelial layer in your cardiovascular system, which includes the penis,
Yes.
has a layer of endothelial cells, and there's fructose uric acid metabolism going on there. So when you activate fructose uric acid metabolism in the endothelial layer, nitric oxide metabolism gets dysregulated there too. But exactly what the nuances are, I don't know exactly. I know that when you downregulate nitric oxide in the liver, now you have less of it that's being expressed out into the circulatory system. And that has an effect on vasodilation and vasoconstriction. And so in the penis, where you have this dysregulation going on, it has an effect on the ability for those capillaries to for that system to fill with blood the way it should. Yeah. And I need to be careful, because one of the problems here that I've discovered is that when you switch from one fructose uric acid tissue system to another, there's nuances in how those cascades are working. Like when you look in the chondrocyte, it looks like, and don't write this down and take it to the bank, but it looks to me in the chondrocyte that when you have this rise in uric acid, that instead of downregulating the nitric oxide, it seems to be upregulated. So anyway, my point is that at first glance, that looks like, okay, so maybe all of this is wrong then. But then I think about it and I'm like, well, why would the nitric oxide regulation in the chondrocyte be the same as it is in the liver? They have different functions. And you don't just see this here when you look at other related aspects of this, like what's going on in the brain in the astrocyte, and what's going on in the liver, for example, and then in the chondrocyte, all these cascades of kinases. There's differences in how these things are being operated on. And I believe that has to do with the fact that they all have different functions. So I'm not overly concerned about the fact that it looks a little different. What I wish is that there would be a more central concerted effort to look at the relationship of fructose uric acid metabolism to these other biochemical pathways in all of these different systems. I think it would be really great. Sometimes I fantasize that it would really be awesome if we could have a conference where all these specialists of their respective systems get in one room and go, all right, here's what we need to do. They need to acknowledge that this pathway is instrumental in how we process macronutrients. Like, and then everyone decide we're going to have to look at this in a more systemic way and figure out how we can start tying all this together, because there definitely is a relationship. And I don't know how, I'm not sure how we do that. Sometimes I fantasize about it. And then I'm like, all right, well, I could write some emails. Let's see how far I can get with this. But it's really hard, actually.
Yes.
Pete,
Okay,
I had
thank
a
you.
couple questions. Yeah. I've experienced the issue where I'm kind of a little bit farther down the road on the carnivore paleo eating. And the issue I run into, especially when I do intermittent fasting, I tend to, I'm well overweight, but when I do intermittent fasting, with this type of eating, if I drop weight quickly, that almost always triggers a flare up. I don't know if you've experienced that, but it's almost like, I get into a real good groove, and then I get hit. So I'm trying to figure out how I can kind of slow down the weight loss, so as not to trigger a flare up. Have you heard of that before?
Absolutely.
Okay.
You're talking about a complaint, which is, I would have to say, if it's not the most common, I honestly think it is the most common. It's the number one complaint.
Okay.
And it to the degree that I basically recommend usually not doing intermittent fasting. If you're in the phenotype that you're describing. So people that are really, really overweight, when they start doing this and they do intermittent fasting, what's going on there? You're getting this massive fluctuation in uric acid. And part of the reason for that is because generally with that, you see this big spike in ketones. And the ketones are competing with the uric acid at the level of the kidney. I think that's one of the main reasons this happened. So usually what I advocate for is taking the long game with this. In other words, looking more closely at altering the amount of fat coming in and lean protein back and forth, right? You're carnivore. And letting the weight loss go like that without also bringing in on top of that the intermittent fasting. Now, I'm not saying intermittent fasting is bad for you or that it's not healthy, but you're kind of up against a wall with this, because you want the weight loss, which is going to always result in a lot of ketones coming up. It's like, I notice I don't have the same phenotype as you, but once I got keto adapted, which is going to require literally your weight coming off all the way, right? What do I mean by all the way? Well, you're going to have a set point somewhere, and I don't know what that looks like. I know where it is for me at this point, but it took me a few years to get to the point where I'm at. And I'm completely weight stable. I don't even have to pay attention to what I'm eating anymore at all. I mean, I just weight stable. That's where you need to get to. And you have a personal point at that. Now, when you get to that point, I'm thinking, or this has been my experience with clients too, I'm thinking your ketones all of a sudden are going to plateau, and they're going to plateau low. Now, there's a lot of guys in this space that are going to go, oh my God, what do you mean your ketones are 0.5? You're not in ketosis anymore. You're not fat adapted. And you know what? They're wrong. Basically, what happens when you get to that set point now is your body's going to be, it's going to be more metabolically stable. And if you read Noakes's work, Tim Noakes, you have at that point achieved what real metabolic flexibility is. So you're still going to have fat on your body. It's not going to be gone. I still have fat on my body, but your body is going to be fluctuating between the glycolytic pathway and the fat burning pathways appropriately. And you will find your natural hunger and all of that is also it's going to change operationally. Like you're going to find, you might even find, like with me, with my exercise, I'm now eating 3 meals a day, but for almost 4 years of my process in this lifestyle, I was only eating two meals a day, but the amount of fat that I was carrying around was significantly more. And my ketone load coming off was higher. I mean, I can remember like literally a year and a half ago, my average ketones were between 2 and 3 every single day, no matter when I tested them. Now, my ketones are literally rock solid at 0.5 in the morning. And depending on how I'm doing exercise in the afternoon, they're still usually pretty stable, but sometimes maybe they're around 1.2 because I did exercise. So anyway, I think at the stage where you're at, you may want to not intermittent fast for a while. And see if you can get better balanced with the ketones. It may be for a while if the ketones remain high. Well, okay. I think you need to see where your balance is.
Right.
In other words, like, what are my ketones in the morning? What are they throughout the day after a particular meal? You know, before and after a meal, before and after exercise. So you have an idea right now, without the intermittent fasting, what your cycle looks like.
Right. That makes sense.
Yeah. And when you hit that point, wherever it is, you're going to see the ketones come down. I remember when that first happened with me, I was like, my God, what did I eat the last couple of days? And then it occurred to me, you're not eating any different than you have been. It's the weight. The weight is gone.
Yeah, that makes sense. What one other question I had, I don't think you touched on it, but I know a lot of kind of people that comment on this area will bring up the general hydration. I feel like there've been days where I've kind of been dehydrated and in general maybe, and that's kind of been a bit of a trigger. I know guys like Dr. Berg and some of the other folks that talk specifically about gout will recommend alkaline water like lemon water and really consuming quite a bit of it. And have you come across anything related to general hydration in your kind of research?
Yes, absolutely. I'm going to make a note here because I do not want to forget to bring this up. So the easy thing is that hydration matters. And you're right, I didn't bring it up, but I try to be no less than 3 liters a day.
3 liters.
Yeah.
Okay.
I try to drink all day long, off and on. And then because I'm so athletic, I have to be careful about, pushing the hydration. So yeah, that is really, really important. And the other issues you brought up, sure, the lemon water and whatnot. If they're talking about the citric acid aspect of this lowering, helping with the excretion of uric acid at the level of the kidney, I can tell you right now, I've tried all that stuff, and using potassium citrate directly is the best way to do it. Like, you do have an effect that way, and you can track it because you can measure the pH in your urine. But you need to be careful with it. because some people they get in this mindset of more is better. It's not. You try a little of it, measure pH of the urine. And when I was using it, I tried to be between, I targeted 6 to 6.5.
Okay. Yeah, I know too much potassium can get toxic pretty quickly. But yeah, I already have the bulk citrate form that you showed on your presentation. So no,
Okay.
great.
Now here's the thing I want to tell you about. For this pathway, when it's opened, communicates heavily with the brain. And in the brain, it causes, when this pathway opens, this is fructose dependent, fructose uric acid dependent. In the hypothalamus, it becomes stimulated to produce vasopressin. And vasopressin drives thirst. And in people that are significantly overweight, they are chronically expressing in their circulatory system vasopressin. That's probably the central reason why you're walking around all the time feeling thirsty.
Mm-hmm.
So how do you deal with it? Well, make sure that you stay hydrated. That's a good thing that you're doing. And you should see this effect abate. The more careful you are, well, I think you already are. You're talking about already being carnivore. But when you get to, at some point in this weight loss, you should see the drive of thirst go down.
Got it. One other question. I just looking through the food list. Is there an issue with like brined foods like pickles and say like I make my own corned beef too from brisket with curing salts? Have you read up anything on that or looked into that at all?
So the key thing with fructose uric acid metabolism, and I didn't talk about it in this presentation, but in the presence of the drivers, if you also include salt, that activates the polyol pathway, which collapses into the acute rise in uric acid. So as long as you are not presenting the drivers to the liver, you're not presenting a hyperglycemic event, you're not having alcohol, you're not having the added sugar with the fructose, and you don't have high glutamate coming in, right? Either due to processed food or like overeating something like sardines, then eating something like you're describing should not be a factor.
Mm-hmm.
It's when you have these other things with the salt, you are going to open fructose uric acid metabolism.
That makes sense.
And nobody really understands. Like Johnson has published a whole bunch about this, but nobody really understands how salt, all right, they understand what it's doing. High salt is basically causing a change in the osmotic gradient that's in the blood. What does that mean in English? It means that in the blood, the concentration of the stuff that's dissolved in there in combination or in comparison to water is changed the relationship with the water. And that somehow, because of this increased concentration in salt in the water, increased substances that are dissolved there, changes the relationship, the ratio between the stuff that's dissolved in the water and the water relationship inside the organ, that somehow is activating fructose uric acid metabolism through the polyol pathway. Like their data is unequivocal. They know that it's doing it. but they don't know how it's doing it.
Mm-hmm.
So the key thing is, this is the same argument with alcohol, right? Now, this is a can of worms. So let me just ask to shorten this out. Is there an issue? Do you drink alcohol?
No, I've cut out the main things that you've highlighted, like the sugar, the alcohol, grains, starches, and pretty much been, kind of a paleo / carnivore diet.
So without getting into all the details, because alcohol is multifaceted, it also opens fructose uric acid metabolism another way. But here's the big contributor. That's having alcohol arriving at the liver the same time you have elevated glucose. And under those conditions, it's just like a slide, a children's slide in the park. It's just like, wham, 30% of the glucose is now being funneled into endogenous fructose being produced directly in the liver. And again, how aldose reductase, the first enzyme in that pathway, is being activated by the alcohol, there's not a good explanation for it at all. Just that it's doing that. But then there's another aspect to this that people don't realize. And again, this is coming from work, really high quality biochemical work that was done in the 80s. And these guys were able to show that another alcohol effect happens because when the alcohol hits the liver, it's converted into acetate. And the liver takes the acetate and it converts it into acetyl-CoA. Now, I know I'm getting in the weeds here, but in the process of that two-step transformation, you generate adenosine monophosphate, which gets converted into uric acid. And these guys were able, they were able to show that this biochemistry, it exists not only in the cytoplasm of the cells in the liver, but also directly in the mitochondria. And at the end of the paper, they wrote, you guys, somebody's got to look at this. Somebody needs to take this to the next level and look at if this conversion, number one, is happening to the degree that we think it is, and if it is it circulating, full circle back to this high acute rise in uric acid, but potentially is happening right inside the mitochondria. So anyway, the reason I'm bringing this up is because alcohol, in addition to opening polyol, and then the way I'm describing it to you, it may also be having this other effect, which is going to compound everything that we talked about in this presentation. It's why alcohol is such a profound, I believe it's such a profound activator of a gout flare. So if you are going to drink it, make sure it's really occasional. Which was a challenge for me. I'll just tell you guys that, because I used to be this guy that, I was a rock climber and all this, and I, at a high level, and I believed that I could do anything that I wanted nutritionally because I was going to work it off. And I could get by with these vices. And so I went from drinking 3 beers every day, whether I needed them or not, and having my chocolate at night. I had to give that stuff up. So now I have an occasional drink with my wife, but I'm really damn careful about it.
Dr. Pete, have you heard of any mood changes with the use of drugs? And so when I've tried the sour cherry, and I get very aggressive on that. And when I was on the gout drug, I became quite depressed after about a 6-month period, so I stopped taking it.
You know what? I have heard that. I don't have any direct experience myself, but then one thing I didn't do in this presentation at all is talk about the effects of this biochemistry in the brain.
Yep.
And what you're describing there is right along those lines.
Okay,
So, that's the thing. That's why I keep saying, I think in principle, because of the data I've seen with crystallization in other soft and connective tissues in our body, I'm like, I'd like to get my hyperuricemia down.
yeah,
But these drugs, the side effects
are horrendous.
are brutal, and when I just, in preparation for today, I went back and I reviewed some of this, and some of the stuff that you read, these drugs get glowing reviews. Oh, these are, very well tolerated. But I know in my case, the allopurinol, didn't tolerate it. And when I read some of these other things, I'm like, okay, I don't even know if I'm going back. I thought about maybe having another discussion with my doctor to talk about febuxostat and probenecid or probenecid. And I thought maybe I just don't even want to have the conversation. I don't know, because I'm opening that can of worms again with it.
And whenever I discuss this with the doctor, that's not happening. That's not a side effect, or that's not. They say to me, you're basically making it up.
Well, it seems that there's a lot of people that apparently don't have side effects.
Right.
I have a good friend who's taking 600 milligrams of allopurinol a day, and he doesn't seem to have side effects. But I don't really know the truth of that either on the other side of that coin, because he holds his metabolic cards really close to his chest.
Yep. Yeah, fair enough. And it triggered, you're talking about the part of the brain that has these tissues in it. That makes sense to me in my condition then.
Yeah, because fructose uric acid metabolism,
in the brain.
When you activate fructose uric acid in the liver, and anywhere, I think probably any of the other external organs, what I mean by external is non-brain, right? I think that there's neuronal connections starting with your taste buds.
Yep.
And as soon as the brain knows that you've got hyperglycemia and you've got fructose coming in, I also believe the alcohol component, you activate the dopaminergic pathway. As soon as that activates, you induce a protein that's called delta phos-B.
Yep.
And delta phos-B is a protein that, aside from the fact that all of the hard drug scientists have all come to an agreement that delta phos-B is the pinnacle addictive state protein, what they also all agree on is that delta phos-B drives the natural human state to feed, to exercise, and to reproduce. And when you think about the evolutionary argument here, we needed a driver to send us out and seek certain foodstuffs that would drive the storage, to fill glycogen, to most efficiently get our fat stores back, to reproduce, to be motivated to leave the cave, as a metaphor. And delta phos-B also drives, is tied to depressive states, and it activates other transcription factors, one of which is called CREB, and CREB is driving the withdrawal state, headaches, depression, the need to go back and want things the way they were, all of that stuff. So I can imagine when we start talking about, and I mentioned in this presentation, I'm feeling comfortable enough with this now to argue that uric acid, functionally speaking, plays a very important sensor role in the human. It's signaling to these different tissues what our needs are. I don't know how to articulate this yet directly, but I think that and this is one of the arguments against urate lowering drugs. When you start messing with that balance and you think about the connections to delta phos B and then Krebs, it's not a stretch at all for me to go, all right, there could be side effects that have to do with depression and how you feel, right? So yeah.
Good. So they're not an option for me.
Say what?
They're not an option for me at all.
Okay. I'm not sure they are for me either anymore. But part of the reason I went on them in the first, but besides the fact that I wanted to get my own uricemia down, is I wanted to be able to talk intelligently in these forums about how they work for me and what things happened and, and so on. So it's like weird. Once I went down this lifestyle, I didn't have any problems with gout anymore. But when I went all up here and all, it was like
back again.
I was flaring. Yeah.
And that's because of the rapid changes you're saying.
Yeah, I honestly think you're talking about a dynamic here. Yeah. And you know what? The data out of the 60s, those guys wrote about this in the 60s, 70s, and 80s. I wish that I'd seen this stuff a while ago, or a couple of years ago, but they talk about the fact that, in fact, I have a quote somewhere, I should have put it on a slide, that it's not the average concentration of uric acid that matters. Our data shows that it's the fluctuation. Yeah, and I agree with their data. I think that it's the substantial acute rises and falls that are getting us into trouble.
And is there any data on having a higher rate that causes any other issues other than gout? Is there any other indicators saying that higher uric acid is an issue?
Well, there's epidemiological work, and this is where Richards comes, where Johnson comes in on this stuff. He's like, well, we know that most gout sufferers also suffer from chronic kidney disease, and I think that probably is more related to these sudden acute rises, and then you have the absorption of the uric acid into the kidney, where it can elicit intracellular effects. This also may explain some of the brain stuff. Like we know fructose uric acid metabolism now, if you're willing to step out, if you're not in the Alzheimer's hallway and you look at fructose uric acid relative to what's going on in the brain, that uric acid could be having an intracellular effect in the astrocytes there, or maybe even in neurons by virtue of its diffusion.
Yep.
So unfortunately for you guys, I can't sit here and say, I mean, if you're listening carefully to me, then you might go, well, the hyperuricemia is a problem then, isn't it? I'm like, maybe it is for the diffusion reason.
Yep.
And we have no really good data for that. We just don't. We don't know. There's just epidemiological stuff, which is all that, those pictures of crystals on spines and on the heart valve. That's all. Well, this happened to be there in this individual. Now, did it cause what caused it? That's the problem, right? And I think we have specialized conditions going on with that.
Yeah.
But Okay. Well, you guys are thinking if you have any more questions, I also put the dates in the Dropbox for our follow-ups. And the follow-ups are designed for you guys to basically ask me anything you want about this, right? This is about an intervention. I know one or two of you have already, or maybe all of you you're already progressing. You've already tried, you're in lifestyle, carnivore, ketogenic, whatever it is, you want to ask about it. But those dates are going to be April 27, May 4, May 11, and May 18. And it's in the Dropbox, and the links are there. And like I did for this, I will, the day before, email you the link over again to make sure you have it. All right.
Yep.
And everything's going to be recorded. So if you have to miss the session, the MP4 will be in the Dropbox, and you can, or the link to a YouTube, which is private. Unlisted video will be there, so you don't have to worry about downloading an MP4 onto your computer or something. I think it'll be, yeah, I'll make sure they're linked to a private video. Not private the way YouTube defines it, but unlisted. So only you see it.
Very good.
And Doug, I want to remind you about the issue of vasopressin.
Okay.
Yeah, that's probably why you're thirsty and you feel like this is unexplained. I've had so much water today. It's because you're overexpressing that hormone.
Yeah, I wouldn't say that I feel thirsty. I just noticed on certain days where maybe I'm not drinking enough. I've noticed that symptoms can pop back up again. That's more what I'm dealing with, I think.
Yeah, I think that Vaso's talking to you.
Okay. Interesting.
That should go away when you get to whatever your set point's going to be.
Okay.
Well, do you guys have, do you have anything else?
Not from me.
No, that was a ton of material. Thanks for going through all that. That was excellent.
So I know it's a lot, and I really would like to thank you guys for taking a risk on me and signing up and doing this. And I'm here to serve you. So I have the follow-up sessions coming. Also, if there's something that is bugging you and you don't want to wait for the session, then just email me and I will respond to the email right away. And future sessions that I do like this, the next Gout Intensive, you guys will automatically get a link to it, have access to the Dropbox and so on. And I'm doing that because I really appreciate your support. And this is a long-term thing. And hopefully by then we'll know more. You know, every time I do one of these, I know more than I did last time.
Mm-hmm.
So.
Awesome. Well, thanks again
Thank
for the
you for your
presentation.
passion.
Yeah.
All right. Well, you guys have a good day.
All right. You too. Thank you. Bye-bye.
Bye.
Bye.